Okay, hello. It's it's Friday night. That means it's time for part 18 of N of making a WebAssembly interpreter in Ruby. Um just to recap, I'm trying to write a WebAssembly interpreter in Ruby. I'm doing that primarily for the purposes of having fun. So let's all try to remember that. And by us, I mean me. Secondary goals are I'd like to demystify WebAssembly for myself and perhaps for you. And I would also like to share how I go about doing this, which is to say, just sort of mucking around and seeing how far I can get. I would also like to remind myself that it's more important that I have fun than I build something that's fully functional and implements the entire WebAssembly specification. I want to write correct code that does what it's supposed to do, even if it's at the expense of performance. I want to write clear code that is understandable to myself and someone else. Hey, Chris, welcome. Thanks for joining. I am trying to write it in pure Ruby, which I've managed to do so far, and I've tried to not have any third-party dependencies, which I've managed to do so far. So far, so good. Hi, Nat. So brief retro, as always, to just, I mean, really the main purpose of this is just to, like, so that I remember what it is that I'm supposed to be doing. What do I think happened last time? Well, what happened last time was I upgraded to Ruby 3.2.0 Preview 3. That upgrade went very well. Essentially nothing bad happened. That was great. And also I got to delete some code, which is always an improvement. So it wasn't just switching over to, the largest change was that I switched over from using mutable structs to using immutable data.define. And that only broke one thing, which I then fixed. So, I feel more confident that, having those immutable objects just excludes a whole class of bugs. Although, they're not deeply immutable. They're only immutable at the sort of the root of the tree of attributes. So it doesn't completely rule out weird problems, but it makes me feel a little bit more relaxed. It was only afterwards that it occurred to me that rather than defining that, I defined a method called with sign on several of the float classes so that it was possible to change the sign of a float. And I sort of copied and pasted that implementation. I probably should have just monkey patched, or should I say refined, the data class to just have a with method that you can pass in an arbitrary keywords into an arbitrary hash, essentially. And then I could just call, float.with sign colon sign plus or something. So I might get to that today. One thing I haven't tried yet in Ruby 3.2 is YJIT, which some of my ex-colleagues at Shopify are responsible for, and I believe is now written in Rust. Now, I've got the Rust toolchain on my machine, so presumably when I installed Ruby 3.2, I got YJIT built by default. I believe that is now the deal. So I might give that a go to see if it makes the tests any faster. I don't know. No shade on YJIT, but I just don't know that my process is running for long enough for it to necessarily have very much of an impact. But who knows? Maybe it will do. So I think I should probably give that a try and just see what happens. So the other thing, I suppose the main thing that I discovered last time is that the primary blocker for rather a lot of the WebAssembly test suite, as far as I'm concerned right now, is my inability to execute the call indirect instruction. So I'd really like to look at that, and maybe if I do that, if I get it working, it will unblock all of those tests at once. And so there might well be a sort of a growth spurt where suddenly having sort of like ground through very slowly several tests, it might be that I sort of reach a critical mass of instructions that actually work, and that might unblock, 5 or 10 or 15 different, I'm being too optimistic now, but it might unblock more than one, is what I'm saying. So that's my main goal for today, is to try and do that unblocking. I mean, it would feel really good to make that kind of progress on the test suite. And there might be other tests that I haven't even tried yet that are also blocked on this thing. So I might do another sort of pass through the tests that are currently there and just look for opportunities to, for others that might just happen to be passing now that I've implemented that critical mass of instructions. So, at the moment, the proportion of the test suite that is passing feels a bit pathetic. So I would like to increase that. It would help my motivation if I could feel like I had more of the test suite passing. So I think that's pretty much it. Why don't I just get straight into the really exciting stuff, which is the tippy tappy. Where did we get to? Fortunately, all the tests are still passing. So even more fortunately, I wrote this. Let me just get this out of the way of my big head. Okay, so oh yes, I think this was the last thing I did. I think I added cool.wast to the pending tests. So this was, yes, I remember this is failing because there's a recursive function call here, which we don't support. These work up to the point where they try to use recursion, which we don't support yet. So yes, I think I have a bit of a choice about whether I care about this or not, because as I said here, well, firstly, this is my ongoing lament to introduce an identifier context in the AST parser so that, well, I'm just reading this out now, sorry, so that the evaluator doesn't have to deal with resolving identifiers anymore. So I've been saying that for several sessions now, and I still haven't quite got around to it. But it's causing me grief that I haven't done this yet. So I would like to try and look at that this time, but I don't know if I'll get to it. This here, make recursion work for call if we need it. It may turn out that we don't. So I obviously we're going to need it eventually, and we need it to make this test pass, but it's not necessarily on the critical path for what I was just talking about, which is what I want my focus to be, i.e. We need call indirect to be working to, and I quote myself here, unblock loads more tests. So I think this has to be the top priority. There's some stuff here about, I mean, I think this is a remark about the fact that if I want to work on global, then at the moment, the test file for globals has got nested comments in it. Let me just bring a browser up and we can just have a look at that. Global.wast. Am I lucky? Yes, I am lucky. I don't want global waste. That sounds awful. So yeah, you can see here it's got kind of winky faces rotated 180 degrees from each other, sandwiching a number. Who knows why they've done that, but clearly that clearly this is necessary for some reason. Yeah, this is actually, I think it, oh no, see, this has got call indirect in it. I was saying that maybe this would be a nice place for us to start, but it looks like it isn't, because we're not going to get this working without call indirect working. I don't know to what extent these dependencies are completely cyclic. Like, does this call indirect test stand alone? See, unfortunately, this has got a factorial in it, which is suspicious because that's quite likely to be recursive. Yeah, there's loads of factorial in here. So maybe I will need to tackle that. But actually, now that I look at it, this call indirect.wast, does it have globals in it? Oh, yeah, it does. Oh dear, and presumably it has table. Yeah. Okay. All right. So it seems like these things are all so interdependent that I don't know if there is any way to just nibble away at one of them without also trying to bite off the other ones. I mean, this, did I already do, did I already add this module.wast? Maybe I did. No, I didn't. I can't remember what happens when I try to run the tests on this. Table. Oh, yeah, okay, so it sort of passes because they're all skipped. But at least, I mean, that's not nothing, because that indicates that there's nothing here that the parser can't handle. So that's something. By which I mean the S expression parser, because at the moment these module definitions don't go through that AST parser, which is a whole other problem. Okay, so yeah, to sort of break this cyclic dependency, I'm just going to need to pick one of these. I wonder if no, I'm probably going to have to deal. I'm probably going to have to deal with the recursion problem. Actually, now that I think about it, it seems unrealistic to assume that I'm going to be able to avoid handling that. I mean, I suppose it's possible that these tests won't exercise it, but it doesn't seem particularly likely to me. What do these calls to Fibonacci functions look like? Yeah, so if we're doing like fib of 20, seems pretty likely to me that that's going to involve you know, I saw in the function definitions that they were sort of potentially calling a different function, but even if they are, it's going to have to recurse after the first, after it gets handed off to another function. There's going to be some recursion. So yeah, I think I'm going to have to deal with that. And then yeah, here's some sort of, you know, some sort of stretch goals here. This was just the stuff I mentioned during the retro. Also, since last time, Chris Patuzzo, who is very kindly and patiently working his way through the backlog of videos of these things, is sort of sending me messages from the past, back from when I implemented the count leading 0 and count trailing 0 instructions. He pointed out that I'm using the square brackets method on integer to slice out like a range of bits from the number, but I'm doing that inside a loop where I sort of start out by slicing out 0 of the bits, and then I slice out 1, and then I slice out 2, and then I slice out 3, and then I slice out 4, and then I stop whenever the amount that I've sliced out is non-zero. But Chris quite rightly pointed out that I don't actually need to slice out that sequence of bits. I can just check the individual bits, because then cumulatively I will have checked all of them. And as long as I bail out as soon as I find the first non-zero bit, I don't need to be slicing out all of the lower or higher bits, depending on whether we're talking about trailing or leading zeros. So that was an excellent point. I've added it to my to-do list here. Along with other good suggestions, like Chris Satter's suggestion that I add line numbers to the assertion output. So, you know, this to-do list is getting longer and longer. Let's do a little bit of cleanup on this, because anything I've already done, I don't need to see that anymore. You know, there's a real balancing act here, because I sort of like seeing that I've checked some stuff off, because it makes me feel like I'm making progress. But after a while, it's just like, it's just taking up space. Okay, so look, I've done all this. I don't need to. That's yesterday's news. Unfolding expressions. Okay, I have introduced an AST, but as this to-do list rightly says, I have not actually finished with that. Okay, all right. So let's focus. So I think I'm going to, in and of itself, I think I'm going to park call unless it turns out I need to use it to drive out, you know, making recursion work. And like I said, I think I probably am. I would say almost certainly I'm going to have to do that in order to make the call indirect test pass. Now, making the call indirect test pass is not the be all and end all of this, because I don't care so much about this individual test script. I care about what it unblocks in terms of being able to run lots of other tests. So I might not need to do that. I mean, maybe I could start with global. It's just a bit annoying because it's got this. But, you know, maybe I just need to deal with nested comments. I mean, of course, the other option is just to go back to, because I made a list of what I think these various things are blocked on. So like branch, for example, says it needs table, call indirect, and global. So maybe I've got the option. I'm just trying to, I know I'm just waffling here, but what I'm trying to do is like just desperately try to identify what's the simplest step forward here, because at the moment I feel a bit sort of trapped by the cyclic dependency that I'm caught in. Let's just see what happens when I try to run this br.wast. Like, how far does that get? Oh, hi Claudia, you think global is my best next step? Okay. Well, okay. But this is already, but BR is already mostly passing. I suppose the reason I'm shying away from global, I think you're probably right. The reason I'm shying away from it is that I'm just really worried that if I even open the S expression parser, I'm going to start tinkering with that. So even though it's not going to be at all difficult to implement nested comments, like that should be easy, I'm just worried that it's going to be an attractive nuisance, and that maybe if I focus on something like this, where it's like a bunch of this is already passing, at least this gives me something to focus on in a way that if I start mucking about with the S expression parser, I might get sucked into dealing with that. So what is this even doing? I'll tell you what, I'm gonna have a brief look at this. I'm gonna do a little investigation into, like, I mean, the only reason I've picked this is because it's the first of my set of tests that are blocked. But ultimately, I think picking on one of these things that incidentally exercises global, call indirect, and table is probably going to be less onerous than trying to make each of these tests pass, because necessarily these tests are going to exercise all sorts of edge cases, and, you know, for the call indirect and the global test to pass, you have to have implemented every aspect of those instructions. Whereas to be able to unblock these tests, which is what I really want to be doing, it might be enough to just pay lip service to implementing them, whatever that might mean, and then see how far I can get, you know, by muddling through. And like here, I can see if I can get BR working, that's one of the dependencies of load.wast as well. So, I mean, I have implemented BR, that's why some of these tests are passing, but it's obviously not all working. In fact, I'm a little bit surprised here. What is happening here? So invoke as BR if value cond. We're getting an exception here, which I think is, I mean, the error reporting is not very good here, is it? But I think this is one of the, like, raises I put in to say that I was expecting the stack to be empty. So let's just have a quick look at that. Yes. So what was this? What's this doing? It's inside the assert return. It's saying call this function with 9 as the argument. So what are we expecting that to do? So this is the reason I'm surprised, is because I thought this would be a problem that's something to do with, or I'd actually assumed that the reason why this test wasn't passing is because I could see that it needs table and call indirect and global. But actually, we haven't got to any of those yet. There's just some other problem. Hi, Marco. Yeah, it is. There is a, especially when it's in this folded syntax, it definitely has sort of schemy vibes. when you see the unfolded syntax gives me more sort of assembly language vibes. So you can see sort of depending on how the plain text syntax has been written, whether it's been written as a linear sequence of instructions or as these folded sort of nested prefix expressions, it definitely has more of a Lisp or more of a assembly code vibe, I think. But, you know, why not both? So let's just think about what this is supposed to be doing. As brif value cond, yeah, exactly. Lisp and assembly vibes. So this is, what is this? So all of these, so this is like testing something as br value. What is that as? So here, like we're testing a branch as block last. So the branch instruction is the last instruction in the block. We're testing it as block value. So this is a block that actually returns something. And we're using the branch as the value. So in this case, we're saying as brif value. So brif is already implemented. This is the condition. Well, I mean, it's sort of irrelevant, isn't it? Because I think the intention is that... Okay, hold on. What is this trying to do? So this is saying br0 i32 const 8. So this is going to unfold to push 8 onto the stack and then break out of the block, essentially, because the 0th block, enclosing block, is this one. So break out of the block if 8 is truthy, which I believe it is. And so all the rest of this should be sort of irrelevant. Oh, okay. So I think that the problem here... So it's expecting the stack to be empty. And I think the reason it's expecting the stack to be empty is I remember reading something about this and ignoring it because it seemed complicated. But now, of course, I have to think about it. It was in, I remember seeing it in control instructions when I was reading about return. So there's a paragraph somewhere. Yeah, the return instruction is a shortcut for an unconditional branch to the outermost block, which implicitly is the body of the current function. So, and then in the operational semantics here, it sort of elaborates on that and says, oh yeah, when you do a return, what you need to do is pop everything off the stack up to the nearest stack frame, basically. So this is saying, like, the assumption is you've got a single stack that has these sort of heterogeneous records on it, where it's like it can be an activation frame, which I haven't implemented. It can be an operand, which I have implemented. And when you're returning from a function, you need to pop everything off until you get to where the point on that stack where the function started executing, basically. And that's what I haven't implemented yet. And I mean, essentially, that's why recursion doesn't work properly. So I haven't really managed to avoid that problem. Anyway, sorry, my mind's running away from this. But the point is that this bit of operational semantics that says, oh, just pop everything off the stack until you get to the nearest activation frame, sort of throw away the entire contents of the stack as far as the currently executing function is responsible. And if there was stuff already on the stack before then, obviously you don't throw that away. But what this section here is explaining is that that's really just a special case of what all branches should do. And that's what the next sentence. This is the sentence that I was afraid of, that says, taking a branch unwinds the operand stack up to the height where the targeted structured control instruction was entered. So essentially that means oh goodness, I'm reading the next sentence. However, branches may additionally consume operands themselves, which they push back on the operand stack after unwinding. Branches may additionally consume operands themselves, which they push back onto the stack after unwinding. I don't understand what that means. I'm a bit unclear about what the order of operations is supposed to be here. Let me see what the operational semantics of branch are. So maybe this will clarify. So due to validation, the stack contains at least L+1 labels. Yes, this is kind of like legal. You're right, Claudia. This is kind of like legal boilerplate, but for computer programmers. So the stack. So this is where we're saying, let's say, in this case, we are. Let me close that for a minute. So we are doing BR0. That's the branch that is happening. So this is saying, in particular, the stack contains at least. Oh yeah, you can also put labels on the stack, which I'm not doing. So the stack contains at least one label, which it does at this point, because we're saying that this block has got an implicit label of 0. Or, it's got the 0th label. Let L be the 0th label appearing on the stack. Let N be the arity of L. So I guess the arity is, well, I don't know. Maybe it's how many results it has. Does it return 0 things or 1 thing or 2 things? Due to validation, there are at least n values on the top of the stack. Right. Okay. So it's saying, like in this case, I think this is just my interpretation of this. I don't know if this is right, but I think what this is saying is that this block here has got a single result. It's got a 32-bit int is the result of this block. Okay, so it's got one result value. So we can say the arity of that block's implicit label is 1. So we're saying the arity is 1, so there must be at least one value on the top of the stack at that point. Now, is that true here? So we're doing a BR if we've pushed 6 onto the stack. We've pushed 9 onto the stack. And then we consume the 9. We consume the 9 in the BR, but we've still got this 6 on the stack. So I think that's saying that we should pop the 6 off, empty the stack, and then push the 6 on. Is that right? But then this is drop here. So it's expecting the result of this to be 9. Okay, well, I'm very confused about what the return value of BR is supposed to be in that case. Oh, sorry, I wasn't thinking clearly. So BR if is a conditional branch, so that does take an argument. BR by itself is an unconditional branch, so this is not one of the arguments to BR. This is the return value, right? So once this has been pushed onto the stack, and then we say BR0, this is the thing that ends up getting returned as the result of the block. and presumably we would otherwise be returning 7. So what is it that's going wrong here? I think maybe it's that at this point, there's still a 6 on the stack. So even though I expect... Okay, so my assumption is that let's put actual values inspect. I would hope that what we see here is that we have correctly returned a single... Yes, I think we will have correctly returned a single value, which is 9, because we know the result arity of the function. So this thing here knows that... oh no, in fact, it's not even looking at that. It's just looking at what the assertion is saying. The assertion's looking for one value, so we're going to pop one value off the stack, and that'll be fine. But because nobody has even tried to remove this 6, I think that's still going to be hanging around. So I expect if I do remaining stack, stack.inspect, we'll see that there's still a 6 on the stack. Yeah, so that's exactly what happened. So that's good. That validates my understanding of the problem. So, like I said, at the moment, the implementation of the return instruction, there's this to do in here, is that it just empties the stack. And it's got this... Again, this is a special case, right? The arity of the outermost block when you do a return is the arity of the function. How many return values does the function have? That's what it's using function.results for. But when it's a regular branch, br or brif or something, it turns out that I need to unwind the stack to the right depth. So this business here about while the top of the stack is a value, pop it from the stack, that means throw it away. And then it says now you should have a label on the top of the stack. So again, this is assuming that you've got a single stack that interleaves block labels and function activation records and operands, which I don't have. I've just got the operand stack. So I need to find a way to achieve this effect without doing literally what this is saying, or to change my approach so that I can do literally what this is saying. I don't think I do need to do it literally, because it feels like I should be able to use the Ruby stack for keeping track of what label are we inside, what function call are we inside. That should be evident as part of the Ruby call stack. So I shouldn't need to maintain this manually. But yeah, it does mean that I need to find a way to make this work. Yeah, I don't really understand that sentence I read before. Taking a branch, oh no, this one. Branches may additionally consume operands themselves, which they push back on the operand stack after unwinding. I just don't understand that. And this doesn't say anything about the... yeah, it just doesn't make sense to me. I'm sorry. I don't know what that means. This is much clearer, because this just says you need to know what the arity of the elf label is. And that's how many values you have to... So there are 2 stages to this. I'm going to start commenting this in so that I don't completely lose my mind. So we need to do something here that's like, pop off the right number of operands per target block arity and save them. Unwind the stack to the correct height for the target block. restore the saved operands. So effectively what this is saying is that if we're inside some number of nested blocks, I think, yeah, it is really, it doesn't matter what the arities of the intervening blocks are. The only thing that matters is what's the arity of the block that is receiving the branch. Now, the thought immediately occurs. See you, Claudia. Thanks for coming. The thought immediately occurs that I might be able to deal with this, not because all BR does is just throw this symbol, and actually BR doesn't know which of the enclosing blocks is going to catch this throw. It just it knows that it's the 0th or the 1th or the 2nd or whatever, but 1th. But it doesn't know what the arity of that block is going to be. However, I think if we deal with this on the other end, if we say, well, it's actually the job of the block and the loop, and if, maybe not. I certainly don't have any catch in here. I don't know if that's right or wrong, but at the moment we're not making any attempt to catch stuff in an if, but it's block and loop that have the catch block. So maybe at this point, I mean, at the moment the AST doesn't know anything about what the arity of this block is, but maybe if it did know that, then it would be able to do that, to do the stack unwinding operation here. So I'm going to rethink this. Unwind the stack correctly. Else, come on, throw. So the throw here is just, that's just punting it to let an enclosing block deal with the problem. And this is a similar deal. So I'm not very happy about the fact that this is duplicated, but the reason it's duplicated is because I don't have that identifier context. So I'll just have to live with the fact that I still haven't done that. It's still causing me pain. And again, more duplication here. I mean, I think I can just copy this. It's slightly different. This one is the same. Oh no, it is. They are both the same. I'm sorry. Oh. So the question is, what information do I need to unwind the stack correctly? So in this case, let's focus on the case I actually need. So here it's a branch to a number, not to a label. So, and it's a block. So it's going to be, this is going to be the first case we have to deal with. So specifically, what is the block arity? And also, what was the stack depth? Which I think is what this was saying. Taking a branch unwinds the operand stack up to the height where the targeted structured control instruction was entered. So that's talking straightforwardly about the height of the stack. I'll say height here. I believe that it's not only what was the height of the stack, but actually what did the stack look like. I would imagine it doesn't seem like it should be possible to write a block that consumes. I haven't looked at the validation stuff here, but it seems wrong that you should be able to, let's say you've got 5 values on the stack and then you enter a block. it seems like that block should be able to grow and shrink the stack as much as it likes, but it doesn't seem like it should be possible for it to start eating into the values on the stack that were already there when the block began to execute. And so I think that this is equivalent to saying we essentially restore the stack to what it looked like before. So given that that's slightly easier... Oh, no, it's not, because we mutate the stack. I was going to say I could just save... I mean, I suppose I could duplicate it. I could save a copy of the stack. You know, before we evaluate, you know, we could say sort of old stack equals stack.dup or whatever. And then here, you know, unwind the stack correctly is like something something self.stack equals old stack, you know? So, sorry, I don't know what I'm doing there. So this would effectively unwind it, sort of restore the old value of it. So when I say unwind the stack correctly, I mean to do restore the stack to its height from when we entered the block. And that's actually what this is doing. And then we've got push the saved operands back onto the stack. And in order to do that, we need to know what the arity of the block was. So I think maybe these two might be taken care of. Like, I don't know. I don't really like this. This seems a bit silly, but... Well, and I mean, actually, I can... there's no reason for me to do that inside the catch. Let's call it previous stack. So I might try this just to test out my understanding of what's going on here. And then I'll come back and think separately about whether I actually want to do it this way, or if I just want to remember the height of the stack and then just pop stuff off until the stack is that high. Or in fact, I can just do that in one go. I can just pop 5 values off at once and throw them away. Well, so actually, there's a sort of to do pop off the saved operands. And I suppose this will be like stack.push saved operands. Does this need to be splatted? Yes. So it'd be something like that. So this is going to be something like, say, well, you know, stack.pop something into saved operands. And then we restore the previous stack, and then we push those operands back on. Oh, and then this, those question marks, is just block arity. Which I do not know. So this is the real... So I'm sort of... I'm closing in on a solution to the problem here. But this is the thing that I don't know how to do, is to get the arity of the block. And I think the reason I don't know how to do that is because it's not in the abstract syntax. Let's have a look at the AST parser. So, yes. So you can see right now, this code here, when it encounters this result I32, that will trigger this conditional, which will see the next thing in the input. So when we peek ahead, we see that there's this n element array here, starting with result. And then what have we called this? Types elsewhere? I don't know what we've called that. or maybe in the interpreter. Yeah, so this sort of thing. So what I did for functions was that I just remembered these, because we had to do the reason this is here is to make the analogous thing work for the return instruction. And I mean, ultimately, these two things need to be unified, because at the moment I'm sort of re-implementing the same idea. But here it's being implemented for the function body, because the function definition has got one of these result things that tells you, or it's optional. If it's not there, then it doesn't have any return value, and if it is there, this tells you how many return values there are, non-zero. We need to do the same thing for blocks, and in this case I just saved the let's just put that there as a reminder of what I did, names wise more than anything. So I'm going to do the same thing here and just make it look similar. And what I ended up doing here was that probably unnecessary to use concat here, but it's because, well, I'm not sure why I use concat here. That's probably not right, because I think you're only allowed to say result once, but I'm not 100% sure of that. So here I need to put those types somewhere. So actually, I think the pattern I've been using here is like, just let it match here and then read through a pattern that is going to, so that's what I've done above. Read it through a pattern that is going to assign the thing that you care about. So that assigns this types thing, and then maybe I should, how does the syntax work? The label comes first. What should I call what did I call it here? I called it results. Well, I'll give it the same name here. Well, okay, I'm gonna, having bothered to look at the other thing, to look at the naming, I'm just gonna call this results. I'll just do this for block for now, because I'm just trying to get this one example to pass, so I don't need it for loop yet, and I don't want to duplicate all of this into loop if it's actually not right. So yeah, at the moment this is just going to be an array of strings, and we don't even need that array of strings, because it's just going to be, all we're going to care about is how many there are, what the number of those is. I do think I'm going to need to initialize results to be, you know, I think it, oh, maybe I'll do it. No, it's okay. I was going to put an else there, but it gets a bit messy. Well, no, maybe that's okay. It's because when there's an assignment inside a conditional, I would like to pull that assignment up out of the conditional, and you can't really do that with this pattern match. But so I'm happy to just assign it in both branches. So that's gonna let me remember. What was I doing in AST? I was trying to add it to block. Okay. So this needs results now as well. So that's going to remember how many results the block has. Well, specifically what the types of them are, but we're not actually doing anything with that yet. So yeah, that could just as well be a number. And then block. So now we've got access to that now, because that's, the parser has left that in the AST node. And then here, the block arity is actually results.length. So I think I've like answered all of those questions. Let's see. I mean, goodness knows what this has done to my test. uncaught throw branch. Oh, okay, look. This test passes now. So we've got a different problem, but now it's as if then, which is actually at least a few tests on from where we were. So that has actually sort of worked, which is surprising. So what's happened here? Uncaught throw. Ah. So I think this is what I was alluding to before. I mean, what a coincidence. But it seems like this is the point at which we need to start thinking about having if then else introduce a new, I've been calling them blocks, but structured control expression or structured control instruction or whatever it is, because I believe that the target of this branch 1 is supposed to be this block, but because if then else doesn't try to catch these throws, it doesn't have an opportunity to do that business about decrementing the number and then rethrowing it until it becomes 0. So that makes sense that this 1 is sort of right now it's only got this 0th enclosing block. This doesn't count at the moment, so that 1 is out of bounds. So that's what's happened here, is that throw has been, that symbol's been rethrown and no one has caught it. So that makes sense. So I think that means that what I've done so far is probably okay. So now what I want to do is think about, do I want to do this stack.dup business? So does it make any difference if instead of saying previous stack equals stack.dup, if I say, stack height equals stack.length, and then instead of restoring the whole previous stack, can I just say stack pop stack.length minus stack height? Because that should effectively do the same thing, but without duplicating that array and then reassigning it to be the old value. And it makes me a bit uncomfortable to do stuff like this, because I know I said that performance isn't a concern, but this is sort of, if it works this way, then I think this is a bit better, because given that I've already opted into mutating this single instance of the stack, it sort of feels nicer to be able to just keep that single instance and modify it everywhere, rather than have to get into a situation where I've got potentially, if they've got 5 blocks nested inside each other, that means I've stacked up 5 or 4 maybe previous stack instances somewhere, and then they'll all get restored again when those blocks unwind. It just feels like that's got the potential to get me super confused, because then there is not the one stack to rule them all. There are all these sort of stacks that have been squirreled away somewhere, and if the wrong reference gets into the wrong place, then it's going to become basically impossible to debug that. Whereas with this is a much blunter instrument. Let's see if it works. I'll shut up and see if it works. All right, well, it does work. It's still failing, but in the same way as when I didn't have that. So I think that's the way I'm going to play it. So I'm going to remember the stack height. And then the thing that we need to do is pop the save operands off the stack, restore the stack to its previous height, and then push those saved operands back onto the stack. Yeah. So that is always going to be unwind the stack correctly, right? I'm just going to inline it for now, and then I'm going to think about, well, because I know that the very next thing I'm going to do is also make conditionals have a catch block around, we'll need them around alternative and consequent. I think I need to extract the whole notion of, oh look, I can't actually do that in here yet because I haven't introduced the notion of the results of the loop. I'm just going to do that. I'm sorry. I keep getting halfway through a sentence and not finishing it. What I was going to say was all of this business needs to happen in a single place, right? I need to have something that I can just wrap around this evaluate, and say like with block do evaluate, and then have this with block helper do all of this business to do with catching and so on. But I'm intentionally allowing this code to duplicate at the moment so that it's easy for me to modify it depending on, maybe it needs to be different here for some reason. In practice, I think it's actually the same, but I'm just leaving my options open until I can see everything's working, and then I will come back and reduce, extract the duplicated logic here. So I think what makes sense as a coherent change is, rather than do this lopsided update here where I've added results to block but not to loop, I think it's more regular for me to do it in both places. You can see here that the only thing that's varying in these two cases is the receiver. Everything else is the same, but unfortunately I can't just factor out the receiver because the arguments are actually different for if. So I think this is probably as good as this conditional is going to get. So that means that in the AST, I need to make sure that I've added results to loop as well. I think that I've got a sort of a coherent change to the AST parser there. And I guess I have to add it to the AST. So let me just make it so that that's the only change. And then let's just run through the test to make sure I haven't broken anything that was previously working. I can't imagine that I have. But if I could imagine everything, I wouldn't ever run the tests, would I? Okay, so yeah, that's failed successfully in the way that we were expecting. Sorry, I was getting distracted. This is what happens when your tests take more than 1 second to run, is that your attention wanders. Okay, so I think I've got a commit there, which is something like, what did I say about here we go. Oh no, it's this one. Add result types to function. So I think really this is my model for this commit message, because I think probably that commit to FF317, well, yes, this change should have been in the AST parser, but at the moment the AST parser is not parsing function definitions. So this would have happened inside the AST parser. So I think that's fine. So what did I say here? So firstly, let's say add result types to block and loop. We need to know how many values the block returns in order to correctly implement branch instructions. I sort of need a citation for this. Yeah, I remember there's not a good way to link to that paragraph, but let's... So I'm both going to link to it, and I'm also going to just quote the relevant bit because it's a bit long. I mean, it's a little unfortunate for me to be copying the sentence that I literally couldn't understand. So maybe this is a little bit pretentious because this makes it sound like I've understood something that I haven't understood. But this does at least give the flavor. Unwinds the operating stack, or the operand stack. Yeah, I've just read that second sentence again, and I still don't understand it. I might as well fess up to that here. I don't really understand the second sentence above. Branches may consume operands, but I can see from the operational semantics. Yeah, I mean, it's good to be honest about what you do and don't understand, isn't it? Because I'm writing this for myself. So there's no point trying to sound more clever than I am, because I know exactly how unclever I am, and I am not going to impress me with that kind of rubbish. I don't really understand the second sentence above, but I can see from the operational semantics that we need to pop the right, that if, e.g., the block returns 3 values, we need to pop 3 values off the operand stack before we unwind it, then push them back on afterwards. Is that what the second sentence means? Maybe, but it doesn't read that way to me right now. Anyway, we need to remember the return types during parsing. Okay, well, that's a little bit equivocal, but hopefully that communicates the right amount of confidence, which is to say not very much. But at least I'm being honest. Okay, so what remains? Right, so what remains is, I think I've probably broken the tests with this change, because now I've got catch code inside loop that's not hooked up to anything. It doesn't know. Yeah. Stacked up results. Undefined method length for nil. Is that what I expected to happen? Well, no, not quite, because it shouldn't have even acknowledged that there is such a local variable, but I suppose that everything's smushed together in one place here, so it's not terribly surprising. So, but I also need this. This is the other thing I'm missing, is remembering the stack height. So again, this is part of the generic I am entering a block situation. It seems right to measure this before we enter the loop, rather than measure this per iteration. I think we want to measure this. The label is marking the point before we start executing the loop for the first time, I believe. So we remember the stack height, then we kick off this loop, and then we do this kind of handling. Unwinding the stack. So I think that's going to unbreak these tests, I hope. It's looking hopeful. No, it isn't. No matching pattern error. Line 237 in evaluate instruction. Yeah, I'm going to get rid of those comments because we don't do the work there anymore. Why is it saying... Oh, so silly. Results. I'm sorry. I'm sure that you, dear viewer, noticed that I typed results wrong there. But do you know who didn't notice? This guy. When I watch these videos back, it is frankly embarrassing how easily I make really obvious mistakes. And I don't know how to explain that. So there are two explanations for this, right? And I like one of them more than the other. One of them is that I normally don't make silly mistakes like that. And the reason why I'm making them on the stream is because my brain is having to juggle more stuff. I'm trying to talk. I'm thinking about how to explain what I'm doing in addition to thinking about what I'm doing. And that's taking up some amount of my brain's ability to process stuff. And it gives me this real sort of tunnel vision on the tiny thing that I'm doing, to the exclusion of other considerations like, have I made a typo, or is this the right way to approach the problem? So that's one possibility. And the other more harrowing possibility is that I'm always like this, but I don't normally have a video to prove it. And my selective memory of working on stuff just, humanely elides all of those little moments of making silly mistakes. And when I look back on it, I sort of think, oh, I think I did quite well there. I didn't make any silly mistakes. And that might just be my brain lying to itself. So I suppose it's impossible for us to ever tell the difference between those two situations. So we'll just have to go with, I'm normally actually a really good programmer. And it's just the indignity of doing it on stream that's making me appear to be fully incompetent. No, Marco, I don't it can't possibly be a mix of both. I think it's just I'm normally brilliant, and it's just having the video camera on me that turns me into a gibbering incompetent. Let's go with that. Okay. Case closed. I'm sure you're right. I think it is a mix of both, but I don't like that. Right. So this is a coherent change. I believe that this is yes. So hold on, let's just for the purposes of, because I want to be able to say in the commit message that it kind of got us past this. Okay, so I've got to stop doing that. It's a terrible habit. Okay, so this is unwind the stack correctly after a branch. I mean, essentially, this needs the explanation from the previous commit, but I can't be bothered to type all of that again. So I'll just say, as explained in the previous commit, we need to unwind the stack to the correct height, i.e. After a branch, i.e. to the original height to the height the, to the height of the stack at the time, i.e. to what it was when we encountered the label, and restore the correct number of operands, well, restore the right number of operands depending upon the block's arity. This change specifically causes the test from BR WAST to start passing. Although this exposes new failures relating to the fact that we aren't treating if as a block, which we should be. I'll fix that next. Okay. Oh, I should also say I'm conscious that I'm introducing lots of duplicated code here, but it's becoming increasingly obvious that there's a single enter a structured. Let me get the name right. Yeah. Enter a structured instruction concept that will be shared between block, loop, and if. So I'll continue hacking away for now and extract that idea into a helper once I'm convinced everything is working correctly. Like, yeah, I already explained this. I don't want to prematurely extract stuff that I hope is going to be correct, because then if it turns out that there needs to be some variation, it's just a right pain to go in and weld that into the thing that I've already extracted. Whereas if I wait until the appropriate moment, I'll be able to see that variation in the code that I wrote, and then I can design the thing that I extract to exactly match, you know, how much variation do I need. Like I said, I don't think it's going to vary at all in this case, but it's a general habit rather than something that I'm just invoking in this specific situation. In fact, I've thought of another interesting thing to say here. Let's say, although this is really part of the operational semantics of the branch instructions, e.g., BR if, it's easier for us to implement it as part of the structured instruction, or say instead of as part of the instruction targeted by that branch, e.g. block, loop, because the latter already has all of the necessary information needed to rewind and reconstruct the correct stack. Whereas the branch instruction itself does not know which structured instruction is being targeted. I think that's fine. You know, that sort of explains why have we changed the behavior of branches by not modifying the branch instruction. And it's like, well, it's not really the branch that does it. The branch initiates this process, but then ultimately, the implementation of a branch lives here, you know, like what happens after catch, the continuation of catch, that's all this code, is really part of the branch instruction, but it's just in our program, it doesn't live in the branch case, it lives in the loop case. So I'm not going to write that, but that's my verbal explanation of what's going on there. Okay, and like I said, I think I understand why this is failing. It's because if is not introducing, we are not treating this as a structured control instruction. So now I'm going to have to really think about how that works. So I think it's okay to, well, firstly, let's imagine that we have results here. Well, why imagine when you can do? Let's put results here. Likewise for the AST. Okay, well, that only took a sec, didn't it? So if you imagine it, then in the world of computers, that's as good as it actually happening, because it is all mere thought stuff. So we now do have those results. We are going to, I think, see, I'm not entirely sure about this, but I think that we want to remember the height of the stack again before we've done anything. Is that right? I'm not sure whether that's right, actually. I can't really think straight about that. So I'm going to let the computer tell me, which I know is a little bit of an abdication of responsibility, but I can't do everything here. The computer's got to help me somehow. So I'm going to try remembering. I mean, that, you know, what makes sense? Well, never mind that. Let's look at the operational semantics. When does this push a label onto the... See, look, this is interesting because the semantics here say, effectively, these are rewrite rules. This says, if you're trying to execute a conditional, don't execute a conditional, synthesize a block instruction and execute that. So actually, I believe that this is telling me that this is wrong, because this if doesn't say anything about pushing a label onto the stack. I'm sure that that happens inside here. Enter the block with label L. What does that mean? Let's look at this single step. I don't even know how to read this expression. F semicolon val superscript M block BT instructions end. So what's the semicolon separating? Oh, I mean, this is notationally problematic, I think. But what I think that the separation is here. I think maybe this is. I think maybe semicolon here. Just checking that is a semicolon, but it is. I think the semicolon here is sort of. It's like the list separator. So it's saying that we have F is just the rest of the stack. And then we've got M values on the top of the stack. Right. And the block type, the block has got some arity, it's got some function type that says it takes M arguments and it returns N values. So this is saying you've got M values on the top of the block. Before we enter the block, we pop all those values off the stack and then we sort of squirt them into, oh, right, we don't squirt them into the block. We sort of, oh, I don't know, whatever. I mean, that's at some point I need to get comfortable with reading this single step evaluation relation, but I just don't understand where the separators are supposed to be here. Like there's some structure in this, but like I don't know what this epsilon in curly braces means, and so that I'm sort of wasting my and your time by trying to read these tea leaves, and I just can't be bothered to go. Like, so I've answered my question, which is that because the operational semantics of if are specified in terms of block, and before we evaluate that block, we pop the condition from the stack, then my gut feeling about this not being quite right was correct. So we need to pop the value off the stack first, and then we do the blocky thing. I mean, it really does, given that this is specified in terms of block, it really does make me think, could I just recursively evaluate, could I synthesize a block instruction here and recursively evaluate it? I'm not going to do that because I think that's been done as a sort of a notational convenience here, and it's not a recommendation about how to implement this. I think I can use more sophisticated code sharing techniques than like literally block.new blah and then calling evaluate instruction with that as an argument. That seems a little bit artificial. So we're remembering the height of the stack, but then we do basically need to do all of this, don't we? So I mean, I'm gonna basically just copy. You know, I said I had more sophisticated techniques. Copying and pasting is not very sophisticated. But what I meant by that was I can hopefully extract all of the mechanics of this, because really I just need to stick that, you know, that's all that's changing is the expression that we're evaluating. Maybe I can, no, I'll leave that for now. I was just checking what it was called in those two cases. It's called body. So that is essentially body. Oh no, let's do that. So why don't I extract this? Because I think that does actually make it a little bit clearer. You know, essentially what I mean is it's doing the smallest possible amount of work inside this catch block, right? Which is ordinarily what I want to do, is like, if anything, I mean, I know that it can't happen here, but just conceptually, I don't really want to do any, I want to have done all of the work, all of the prep work necessary to call evaluate before we go inside this catch block, basically, is what I'm trying to say. So we go inside the catch block, we evaluate that body, and then I think all of this is correct. So let's see where that gets us with this test. So previously it was as if then. Oh, this is a different problem. Okay, it's got us quite a lot further. And it's our old friend call indirect, which is where I was hoping to get to. To get to a place where we needed call indirect to work without having to actually deal with the call indirect tests, which are more complicated than I want them to be. So there's something good about this, which is that we haven't had to deal with any globals yet. I can see that we're not very far away from having to deal with a global, but at least we've At least we've got this far. But I think I should probably pause at this point, commit what I've done so far. So again, this is whatever I said before. Add result types to if. And I'll just say, as with block and loop in recent commits, we need to know how many results the body, the consequent and alternative of the conditional produce, so that we can unwind the stack correctly in case of a branch. So arguably I'm going about things in a slightly, well, you know, yeah, no, that's what I'm doing. I'm thinking that the reason that test was failing in the first instance was because the branch wasn't working, but then I think to make the branch fully work, we actually do need to do this. So I think it's okay to have, I could have done a simpler thing, which was just do just the catch bit and not worry about the stack unwinding bit, right? And that would have solved half of the problem. But instead, I'm just by duplicating what exists on the other two, I've sort of solved the whole problem in one go. But I think I solved the problem incrementally. Well, no, I haven't. No, I haven't. I'm just lazy. That's what's really going on here, let's be honest. Okay. Treat if as a structured instruction for the purpose. Oh, well, thank you. I'm glad to hear that all the best programmers are lazy. That's very reassuring. Makes me feel better. Treat if as a structured instruction for the purposes of for branching purposes. Previously we weren't even trying to catch the evaluation of the consequent and alternative of a conditional. So any branch was inadvertently targeting the wrong, possibly non-existent parent block, ancestor block. Now we're handling thrown labels in the same way as for block and loop. So branches now target the correct ancestor block, and we're also, as a bonus, doing the stack unwinding correctly too. This introduces yet more duplication, so it's time for some, well, let's say this does make the test pass in br.was, but it also introduces yet more duplication, so it's time for some refactoring. Okay, so what I was saying was that I want there to be some kind of helper method that I can wrap around this thing. Oh, this method is getting so long, isn't it? So there's some kind of foo. Not faux. That's wrong. That does something like this. I mean, let's just see, are the operational semantics of loop in terms of block? No. So we do need we can't just treat all three of these things as syntactic sugar for block, even though if is sort of that. But I'll use this as my starting point because I think this contains all of the essential ideas. So, well, how about I use this as part of, I think because if is just basically, you know, 3 blocks in a trench coat, I think I can use this foo helper in both block and if, and then I'll need to think at least briefly about how to use it in loop to make sure that I've factored out the bit that varies in the correct way, because in loop we don't just evaluate the block once, we have to be able to jump back to the beginning of it. So let's see. Well, obviously I need to pass in body here. And let's call that expression. Because that's evaluate should really be called evaluate expression, because that is what it does. So we provide an expression. I was sort of imagining that we were going to yield here actually, but as it is, we don't need to, because at least between block and if, I think it's the same thing. So at the very least, that lets me cut down a lot of this guff, I think. I think this can be foo. Well, I can just inline this. I think. Oh, hold on. I need more information than that. What do I need inside foo? I need... Oh, I'd extracted out the remembering the stack height. Okay, so I don't need that. I mean, is that the entire body of block? Yeah, it is. So this whole thing... Oh, but it needs to know the results. It needs to know the results.length, doesn't it? Let's call it arity. This is a bit of a mess. Hold on, did I accidentally delete loop? Yes, I don't want that. So this is foo body arity results.length. So this takes an arity instruction. This becomes arity. This becomes arity. Oh, and it needs to know the label as well. Again, because I haven't done that work in the AST parser. So down here in if, we also need, well, we need both of those things. Label, arity. Okay, well in that case, I'll pull this out. Okay, so that's my first pass at it. Oh, something's gone very wrong. Oh, locals, right. If you want to do evaluate, you need to know the locals. Bit weird. I don't really understand why I'm threading locals through as an argument when everything else is just living on the... It's just living as state on the on the interpreter, but I think it's because locals was one of the first things I introduced before I needed to have any state on the interpreter. So I didn't want to have to introduce interpreter state, but obviously that ship has long since sailed. Is that the same thing that was failing before? Oh, come on. Yes. Okay. Yeah, it's the parsing that's failing because the unfolding isn't working correctly, and then it doesn't know what to do with that call indirect instruction. So that's okay. All right. So this hasn't broken anything. The thing is, I could have avoided passing locals and expression in if this was just yield. Let's see what needs to be different for loop then. Oh, no, this is really annoying. This is really annoying because we need to get out of the loop. That's what varies here, isn't it? Is that we've got this break. So maybe because basically it all happens inside. Well, except for the stack height thing. Oh. This is tricky the control flow here is tricky to deal with, I think. I'm just thinking about what's a tidy way to wrap this up. I might need to get away from this idea of being able to break. That maybe what we do here is that the return value of this function tells us whether there was a branch or not. So if that was the case, then inside here we could say like branched equals foo, body, label, arity, results.length, locals. And then we could say break unless branched. Because if you branch, that means do the loop again. I think something like that is correct. And then we need to make sure that this hold on, is this right? Throw means that there was a branch, so did not throw means that there wasn't a branch. I think the naming here is not particularly helpful. I think maybe the naming here should be, did not branch, essentially. So if it did not branch, then we're going to return false. And in these cases, we're going to return true. Let's say, just for now. I mean, of course, control doesn't reach there in all cases. And you can see that we need to find a way to share this as well. So that's why I'm sort of pushing this into here, is that we might find a way to do that. Okay, so does that achieve what we want to achieve? Oh no, because of the stack height thing. Bother. But maybe that doesn't matter. Maybe that doesn't matter. Maybe it's okay to record the stack height each time. Because it should be the same, right? Like, it shouldn't be possible for this loop. Of course, you know, in general, it is possible for a loop to make the stack just grow. In fact, yeah, maybe it is entirely possible for that to happen. Hold on. No, I mean, by definition, it's not, because if what we're saying is, yeah, what we're saying is, every time you take a branch, we unwind the stack to what it looked like when you entered that block. So if you're inside a loop, you have to branch to restart the loop. And so every time you branch, the stack gets reset. So actually, it's okay for us to record it inside foo here, because by definition, it's going to be the same every time. The design of this language is such that you're not allowed to, you know, to grow the stack by one value every time around the loop, and the stack just gets massive. You have to, if you want to do that kind of work, you have to write things into local variables or into memory or something like that. The operand stack is like ephemeral storage. It's not for, you know, if you want to make a list of 1,000 numbers and do it iteratively, you've got to do that in memory or something, I think. I don't think you can do it on the stack. I think the size of the stack needs to be bounded by, you know, it grows linearly with the number of instructions in the program, I guess is what I'm saying. Not, you can't write a finite program that allows the stack to grow without bound. That's my intuition here. Whether that's right or not, I don't know. Let's run this test and see what happens. Okay, well, we got to the same place, so that's encouraging. Let's just run through all these tests and see if anything else is broken. So that was some pretty major surgery I did on structured instructions. Looking promising so far. Okay, so nothing is broken. But of course I haven't convincingly you know, this refactoring is not very convincing. I mean, firstly, calling this foo isn't very good. I sort of think that this should become a yield, rather than, because at the moment I'm just sort of arbitrarily passing in the expression and locals because that's what evaluate needs. I think it would be somewhat better to remove that and allow the caller to explain what they want to happen. So that means that for block, it becomes foo, label, arity, results.length do, evaluate, body, locals. We have something very similar here. but now this becomes expression. I mean, maybe it would be okay for this. How does that look? Yeah, I think that's actually okay. I think, I don't know why. I know that I've already banged on about doing as little possible work inside the... No, I've changed my mind. Ignore me. Actually, I like the locality of this. I like that we're assigning condition and then we're immediately using condition, and then that is like a dead variable from then on. Like, the live range of this condition variable is as small as possible, and I think that, I mean, who cares, right? But I think that in terms of program comprehensibility, keeping this connection as small as possible rather than having it stretch out over multiple lines just makes local reasoning about the program easier. So I think actually this wins, even though I think I would have been fine to have it in there. And finally, for loop, so this becomes branched equals foo, label, arity, results length, do, and then this thing just becomes evaluate, body, locals, end. Just trying to work out if there's some nice way of dealing with this, but I can't think of one without degenerating into using throw and catch again, which is the last thing we need. So I think this is, so what we're going to call foo. Is it something like with block? I really don't think I can be bothered to factor out this. Because it's only 3 lines. And one of this whole case is going to go away when I make that change, when I introduce the identifier context in the abstract syntax parser, so I don't feel very invested in fixing that. I think that's, maybe it should be, do I say structured instruction anywhere else? I think I do in the AST parser. Parse structured instruction. Maybe it should be like as structured instruction. Yeah. It's not great, is it? But that's the best thing I can think of at the moment. Because that's what the spec calls them. It's a bit unwieldy, but that is what it calls them. It calls the block, loop, and if instruction are structured instructions. So that's what's important about them. And this is what they all share, is this ability to be branched. Yeah, I mean, it could be as branch target, I suppose. Because this is actually what's important. Yeah, actually, I'm going to say that. Okay, I feel a little bit better about that. Firstly, because it's shorter, and secondly, because it more directly addresses what is actually going on in here. Like, what is it? What is it that? Okay, this is true for. This is incidentally true for all structured instructions. But what is the property that they share? It's that they can be branch targets. So it's like this is the role that they're playing with respect to this functionality here. It's like if you can be the target of a branch, you have to be able to do this. As branch target. Yeah, I mean, yeah, I'm just going to leave it as that. I think that's better than nothing. So this is just going to be basically. Let's see, look, I did call it body before, and I was thinking before, like, I wish I'd left this as body. So why don't I just leave it as body, and then that'll have the side effect of making the diff a bit nicer. Yeah. I think that makes more sense. So hold on, what I'm gonna do is I want to talk about the exciting discovery I made about the stack height, which is that it's fine for this to live inside the loop. That's my theory. Yeah, that doesn't make anything worse. So I do just want to talk about that separately, because that is what enables that particular extraction, is by making this part of what lives inside the loop do. That means that I can extract the code including that from the body of the loop there, which otherwise I wouldn't be able to. So I think that does deserve calling out. Remember stack height each time we enter a loop. I'll just use the English word loop there. This isn't necessary, but nor is it a problem, because the stack height will be the same at the start of every iteration of the loop as a consequence of the way loops work, i.e., you have to branch to return to the start of the loop, and branching unwinds the stack. Is that right? You know, for the first time through the loop, because branching can push something onto the stack, depending on the arity of the loop body. But then you would have had to have had that thing on the stack already so that you can consume it in the loop body. So I think it's fine. Marco's saying, even though it's all Ruby, it takes me longer than I want to parse most of it because of the heavy use of pattern matching, right word assignments, and the shorthand hash syntax. Yeah, fair enough. Well, I feel a little bit like that as well, but part of what I'm trying to get out of this project is to use all of those new bits of syntax in anger to make myself more familiar with them. So I do sympathize. I have some of the same problems. But that's one of I haven't put it in my preamble for the stream, but that's like one of my private goals of this project, is to exercise those muscles, get used to newer features of Ruby syntax that I'm not quite so used to reading. And I'm hoping that by the end of this, I'm going to be as fluent at reading those features as I am of, features of Ruby that I've been using for a much longer time. So you do have my sympathy, but that is pain that I'm generating intentionally for myself in the hopes that I'll get over it. What was I saying? This isn't necessary, nor is it a problem, because the stack height will be the same at the start of each iteration of the loop as a consequence I lose weight after the branch to return to the start of the loop and branching onwards the stack. I want to make this change so that it's possible to extract the body of this loop and share it with the duplicated code in block and if. Okay, so that has explained that change. So now this is extract as branch target helper. So what do I want to say here? I'll just say all three structured instructions, block, loop, and if, have to work as the target of a branch instruction, e.g. br. Well, let's be consistent about this. So we need the catch handling and that's gonna let's just do that for now. Catch handling and stack unwinding logic for all three of them. This helper encapsulates that logic in a single place and allows it to be shared between the implementations of all three instructions of the structured instructions. Okay. Well, I'm not super happy with it's still quite verbose. Like I said, I've got all of this. I know this speaks to your point, Marco, really, that like part of the reason why I think this code is difficult to parse at the moment, aside from what you've called out explicitly with the effectively the new Ruby syntax that I'm using here, is that it's still not particularly well organized. I feel like this is all just sort of smushed together at the moment. And like these methods are really long, like that doesn't help. So I do feel like I need to come and do a number on this at some point to, well, for example, break it up into lots of smaller files. I would find it a lot easier to read and to navigate and to understand if it wasn't, you know, this file is 678 lines long, which is way too long. So yeah, I think I'm starting to struggle with comprehensibility of this code a little bit, which, given that one of my explicit goals is to make the code clear, is not very encouraging. Although I suppose there's a slight difference between clarity and, you know, comprehensibility maybe, but obviously those two things are extremely related to each other. Oh, I should have said something here. The as branch target helper returns a Boolean to indicate whether a branch occurred or not. We need this so that the implementation of loop knows whether to terminate the loop or not. I'd previously done this with a break, but that's not going to work across methods or even within a nested block. So we need to do it with data instead. I'd like to find a neater solution to this. Maybe some kind of callback. I'm not sure how that would work either. Cool story. Okay, well, the TLDR is that I don't know how to do this more nicely, so I'm just going to wing it. So I suppose I'm probably overdue adding this to my list of pending tests, aren't I? Maybe I should do that before I forget. BR. Let's say, what do I normally say? Add br.wast to pending tests. I want to get the table, call indirect, and global instructions working, but each of the test files for those instructions seems a little intimidating because it immediately depends upon having the others implemented. Instead, I've decided to chip away at BR, which is an instruction I've already mostly implemented, because although it does rely on all three of those instructions, it does so a little more gradually and a little less thoroughly, e.g., I'm hoping I can get away with the fact that I don't support recursive function calls properly yet. Okay, and then I suppose I should... When did I actually start caring about this? I think it was here, actually. Like this is when I started chipping away at BR. I just didn't add it to the test script. So now when I run this, I'll just leave that going, but it's gonna have even more spew at the end because it's gonna run both call and BR. You know, it occurs to me that I might have the necessary mechanism for implementing recursive function calls properly now, because I think it's just a problem to do with the stack height. So I've sort of got all the machinery I need to solve that, but I'm going to disregard that for now and try and stay focused on what I've decided I'm going to do, which is just get this get call indirect implemented and get this BR test passing. So all right, so we're going to have to bounce over to the AST parser again and teach it about call indirect. What is the syntax of call indirect? Call indirect looks like it takes a type. Well, for the purposes of this file, does it always take a type? Type, 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 type. Yeah, so as a simplifying assumption, let's assume that it's always got this. In fact, let's just look at the... I don't know why I'm trying to avoid learning something. That's really antithetical to the purpose of this project. Does this mention call? Okay, so call has to always give a function ID. Call indirect has to always give a table ID and a type use. Okay. What's this call indirect X table ID Y? What's Y? Is Y the type ID? The call indirect function calls a function indirectly through an operand indexing into a table that is denoted by a table index and must have type funcref. Since it may contain functions of heterogeneous type, the callee is dynamically checked against the function type indexed by the instruction second immediate, and the call is aborted with a trap if it does not match. Okay, well, I'm going to ignore that second thing. I'm just going to assume that validation has... Oh, no, I mean, it's saying that validation can't... Right, it's saying that... Yeah, okay. It's saying that you can't actually check this with validation. So for now, I'll raise an exception if... No, I'll just ignore it. I'll just ignore it. Sorry, that's a diversion. So I think I can just ignore that second immediate, but basically call indirect's got two arguments. That's what we need to know. For the purposes of unfolding, that's what we need to know. Call indirect... So what are the... I guess this is... what's I prime? Some kind of identifier context or something. Yeah, I don't know. Yeah, it is the identifier context. I'm not sure what the I prime means in this, but for the purposes of unfolding, because this is a folded call indirect. Oh, what am I missing here? Give it a table ID. You give it a type use. Oh, but is type use itself potentially... A type use may be replaced entirely by inline parameter and result declarations. In that case, a type index is automatically inserted. I mean, this suggests to me that it's okay for this to be empty. Type $sig. What am I not understanding here? This is not the easiest thing in the world to follow, I'm afraid. Call indirect function calls a function indirectly through an operand indexing into a table that is denoted by a table index. So what that's saying is this thing has got a dynamic arity of 1. Like when you evaluate call indirect, it's going to pop an operand off the stack and it's going to use that as an index into a table. So that all makes sense to me. We've got this table, funcref, and it's got this element $f, and then this is calling that function. Type. I mean, I'm looking at a bad example of it. This is the one that we actually care about. So yeah, that one we were looking at was was supposed to be wrong. So this one says, I don't understand what's happening here syntactically. I don't understand where the immediate arguments for call indirect are. This is saying you have call indirect, you give it a table ID. That has to be either an unsigned integer. Oh no, hold on. Yeah, it has to be either an unsigned 32-bit integer or an ID. So that's something beginning with $. And you have to give it this type. A type use is a reference to a type definition. So you can just say type, dollar, whatever. And that's what this is. But where's the thing that tells you what table it's referring to? Like, is there an abbreviation? Oh, for God's sake. For backwards compatibility, the table index to call indirect can be omitted, defaulting to 0. Okay. So if it's a call indirect immediately followed by a type use, then that is the same as call indirect 0 type use. So, all right. Oh, this is a painful language to work with. So I don't have, one of the items on my to-do list is to be more systematic about abbreviations. Decide on a systematic approach to S expression abbreviations. I have not yet done that. As you can see, I've got several stretch goals here that remain unfulfilled, and one of them is to have a phase probably that just expands these abbreviations rather than doing it ad hoc, but I don't have a good way to do that yet. So I think essentially what's happening is that's the abbreviations are being expanded during expression unfolding at the moment, which is a little bit dangerous and probably wrong now that I think about it. Maybe it's not safe to do this kind of thing here because there's nothing to prevent you using this particular abbreviation. Like in this case, the abbreviations I think are specific to instruction unfolding. Although actually I'm now not very confident of that either. Yeah, maybe it is okay actually that let me just bottom this out in my own mind so that I don't worry. So the abbreviations that I support at the moment are to do with structured instructions. So what's going on here is that, I mean, essentially, in fact, I suppose that there's only one abbreviation that I support, which is that the else is optional in a folded expression. And when it gets unfolded, the else will be inserted regardless of whether it was... Oh, no, look, it is a problem. I don't think I'm doing anything to deal with that. Yeah, I'm not. Crap. So there is a legitimate problem there with block instructions. I need to write that down. Fix the problem that the if abbreviation which allows the else to be optional only works for folded expressions at the moment, but it applies to unfolded expressions too. Because we reinsert the else during unfolding. But yeah, actually, so when you look at the unfolding process, even though the else thing here is optional, it unfolds to an expression that always has the else in. So I was like, well, that's that dealt with. But it's actually not dealt with it, because you can just write an unfolded expression, and this is a legitimate. So these are the two problematic abbreviations, right? This one, which I haven't dealt with, where actually you need to be able to, when you're reading the consequent of a conditional, you need to be prepared for it to be terminated either by else or by end, because there might not be an else, and I just haven't done that. You know, when you're reading the consequent, you're looking for an else. There is no support for it being terminated by end, and then we're always trying to parse out the alternative. So that's not right. So that's great, but that hasn't caused a problem yet, so I'm just going to leave it. So, but I do need to deal with this. I need to have somewhere that I deal with the fact that the table index is optional. What a pain. Okay, well, let's think about it in the context of unfolding first. I mean, basically this logic needs to be duplicated. We need to, I think, as far as possible, the only sensible thing to do here is, and I haven't done the sensible thing. I haven't done the sensible thing with unfolding if. I think the sensible thing to do is to allow abbreviations to survive unfolding. So unfolding doesn't expand abbreviations, it just unfolds. And, you know, if the conditional that you provided initially didn't have an else, then really I think it should be unfolded into a conditional that doesn't have an else. So it's sort of essentially preserving the abbreviation status of the instructions it's unfolded. And then the parser, this thing, parse instruction, just needs to be able to deal with, you know, in parse structured instruction or parse normal instruction, we just need to deal with those abbreviations. And at the moment we don't. So yeah, it's going to involve duplicating work until I do this increasingly unlikely seeming represent the staticity of each instruction in some kind of data structure, or indeed this unfold and parse together so that knowledge of the staticity, you know, and possible abbreviations of each instruction it lives in one place, and possible abbreviations. But for now, it's just, I'm just going to accept that work is going to be duplicated. I'll just keep typing keep typing J's into that note all the live long day, if I had my way. Okay, so there's a special case for BR table because it has a sort of a weird vararg type arity. And now we've got call indirect, which is the opcode, and then we've got the rest. So what have we got here? There might be a table index. How do we know if there's a table index. What does that look like? Okay, it needs to be numeric or an ID. So same as this. Except it might not be there. So this needs to be if rest in that. We get rid of those. Get rid of that. So if rest matches that, then we have to match through that to pull out the index, and then that modifies the rest. Well, else index equals 0. We're not going to do that here. Oh. Yeah, okay. Yeah, what I just decided was that this shouldn't be... This needs to tolerate the abbreviation, but not remove the abbreviation, because the parser needs to be able to deal with code that hasn't been through the unfolding process, because the instructions that it receives might not be folded. So I shouldn't... There's no point in me doing work here to undo the abbreviation. I just need to preserve what is already there. So that is trying. That will... Hold on. This is nonsense, isn't it? So this needs to be like this. So if rest matches that pattern, then we're going to pull out index and rest from it. So that's consuming one thing off the front of... That's optionally consuming the table index. Which will otherwise be nil. So we're going to have to be doing some compact shenanigans here. So what we're going to end up with is opcode. Well, it's going to be rest flat map unfold, then the opcode, then the index, and then the type use. And that whole thing's going to be compacted so that if the index is not present, it is going to disappear. But I haven't read the type use yet. I think that this is mandatory. So I think this is going to be type use. And then what does that look like syntactically? I mean, in this case, it's just an ID. So maybe that's enough to get started with. Yeah, I think I will do that. So it's just the word type. And then an ID. So that thing becomes the type use. Do we have anything else like that in here? No, I don't think so. Okay, so that unfolds it. Right, so that's good. So previously, the parser was, because that instruction wasn't being unfolded correctly, it was finding an instruction called $sig, which is obviously not right. Now that it is being unfolded correctly, it's looking for an instruction called call indirect, which is correct. So I'm very conscious that we're just ignoring this table at the moment. I'll have to come back to that. But assuming we didn't ignore that. Is that the only table in the whole file? Yeah, it is, outside of this assert invalid, which I'm ignoring for the time being. So that's the only one. And yeah, okay, I mean, it's also relevant to ask what... Well, I suppose we know what it does. Let's see what it does in this case. I'm expecting that what this is going to do is pop an operand off the stack, use that as an index into the table, so how does that... Well, I guess it's... Oh, hold on. This isn't even really going to have a chance to do anything, is it? Because we're going to branch... We're going to branch out before the indirect call can happen, I think. So maybe I can make this test pass without really worrying about the semantics of call indirect. Because as long as it... You know, all this business is going to get unfolded. And so this branch is going to happen before the indirect call happens. So as long as the unfolding works correctly, I think this instruction is... I think it's going to work even if I've just sort of implemented it as a nothing instruction. So, but I do need to parse it. Where does call live? Yeah, I think I'm going to need to again do a call indirect. Let me just remember this, because it's going to need to be... Unfortunately, it's going to need to know the same things that code does. So this is just switching on the opcode, and then... Right. So now the game we're playing, this is why I got a bit confused earlier, is that now we're actually consuming the S expression. So... Yeah, which I now realize I was getting confused here. My brain has switched into this mode where I need to do this test before I match it against the match it against the pattern, not regular expressions again, please. But you don't need to do that. This can just be rest in this. So that was unnecessary. It's because I was thinking about when we want to peek versus read. But this is fine. This will either succeed, in which case, again, don't get me started. If this succeeds, these local variables will be assigned. If this doesn't succeed, these local variables won't be assigned, because fortunately, it's going to fail right at the beginning. It's not going to be able to assign this index and then check to see if rest can work. It's going to only proceed if the first element of this array matches the regular expression. Right. So given that, I mean, ironically, I do actually need to do something like that here. So this needs to be if peek in, and this needs to be read. Now this is all the stuff that I erroneously did last time. Something like that. Else index equals 0. So this is where we need to support the abbreviation because if the table index has been provided, then we want to read it. Otherwise, we just want to assume 0. And I think that's... No. I was going to say that's similar to what we're doing elsewhere, but I was remembering something which I have now removed. So never mind that. And then the type use is non-optional, right? So we have to read through this to get the type use. What do I actually care about from this? And in fact, what does type use... Oh, I was just looking at this. What does type use look like syntactically? Just a single type ID. Again, in this same style. So I don't need... Previously, I wanted to remember the whole type use because I was just unfolding, but now I think I need to... remember this somehow. This is the type index, and this should have been the table index. So let's do the same in unfold. And let's be more specific about the syntax of this, just for the sake of it. Really, this regular expression should live in a constant because I've copied and pasted it all over the place. So that's something to clean up next time I feel like I'm in a stable place. Okay, so did I actually make that change? I made a change, but the wrong one. Because I got distracted by something different. So that's table index, type index. And then I think that's what this instruction knows about, right? Table index, type index. So the AST is going to need basically this. This becomes data.define, and these become symbols. So hopefully now we are parsing that successfully, and I would want the evaluator to complain it doesn't know how to evaluate it. No. Parse normal instruction, $A, no matching pattern error. Oh dear, I have made a mistake. Oh, hold on. I should have paid more attention. We have got further. So I was right that actually, well, I was more right than I realized. We don't even need to implement that instruction in the interpreter to get over that hurdle. So this is even easier to implement than I thought it was going to be, because execution never reaches this point. We branch out of this block before we even try to evaluate this instruction. So it turns out that for this test, all we needed was to correctly parse this, and it doesn't execute anyway. So now we're back in the same situation where we're trying to evaluate global.set, which is something that I don't know how to do. And just looking at this, I think that we're probably going to be in the same situation here where I'm successfully ignoring... Did I explicitly ignore this? In here? Yes. So actually, I have seen this before. Otherwise, I wouldn't have put this in here. I have had situations where there have been table and global instructions, which I have been able to simply ignore for whatever reason. So this one is being ignored. I mean, it's not like these global variables are going to be difficult to implement. It's just that like I'm putting it off until I have to. And as yeah, I think I think I'm still not going to have to, because it's the same deal that in, I know this looks like the argument of global.set, but once this is unfolded, we're gonna do i32.const1, and then we're gonna do branch 0, and then we would be doing global.set $a, but we'll never get to it because of the unconditional branch in its argument. So we're not going to need to implement that instruction, at least not for this test. How much globalization is there? Oh, yeah, okay, it's just that then, because I'm ignoring the contents of insert invalids for the time being. So yeah, I think if I can just parse global.set correctly, then I'll be laughing. So, okay, all right, well, that's some progress then. Let's figure out how to explain it. Well, I think there are just two things here. One of them is unfolding. What did we say about unfold in AST parser.rb? Okay. Unfold the call indirect instruction. This is slightly fiddly because of, let's link to this. Oh, I'm not using tabs very effectively, am I? Let's just go straight there. It is in text format instructions. Because of an abbreviation which allows, so let's stick that in, the table index to be omitted. I've decided for now to not expand any more abbreviations inside unfold, because doing so for if has created a situation where the abbreviation is supported for folded instructions, but not for already unfolded ones. So I'm not inserting the default table index 0 into the unfolded expression. Instead, I'm allowing the actual abstract syntax parser to deal with the abbreviation in the final unfolded expression. Okay. I think that's all good. And for this, I really want everything but the puts. Same question. This time I'm asking about parse normal instruction. Parse the call indirect instruction. Per the explanation in the previous commit, this code is responsible for dealing with the abbreviated form of call indirect. And hold on. This isn't really finished, is it? because it's not even trying to turn this into an integer. Okay, let me finish this and then I'll... this code is responsible for dealing with the abbreviated form of call direct and setting the table, the instructions table index to 0 if 1 is not specified. But I'm not actually done with that because... don't need that. So what do I do with branches? Because they're the... right, I do this. If it's... again, because I don't have an identifier context and these are leaking out into the evaluator, I need to either leave the string intact or interpret it as a base 10 number. And it's important that I do that here as well, because if this happens to match a number, I don't want it to be a string. I want it to be a... I want it to actually be an integer. So all of this... again, there's clearly a helper method I need here that does this job. But I'm trying desperately to not get distracted by cleanup until I absolutely have to. Okay, that is correct. Okay, good. All right. Next annoying problem. And let me just run the tests all the way through while I'm thinking about this, is global.set. So this is somewhat mechanical. We're just going to need to do the same thing again. Is global.set less annoying is what I want to know. I mean, I'm going to assume that is the same amount of annoying as local.set. So I'm just going to put global.set in here and look for a different error when I run the test, which indicates that that the unfolding has succeeded. Yes, now it doesn't know how to parse the global.set instruction. So that's fine. Where does local.set get dealt with? So again, can I just sneakily squeeze this in here? Can I just say that we also want to support global.set? And it takes an index of a global. I mean, I haven't looked this up, but this is what it looks like. So in this case, it's actually taking an ID. And then ostensibly there's going to be a value, because this is saying as the, a branch as the value of a global.set, which is what this is. But unfortunately, evaluating this value will cause control to leave the function, or to leave the block at least, and then that block is at the end of the function body. So global set is never going to get a chance to execute. But it looks like this whole thing is going to work fine. And then the AST is just going to need that. Yes. Okay. All right. So that was a lot easier. Unfold the global.set instruction. And then this is parse the global.set instruction. And I don't think there's anything interesting to say about either of those because that's all completely mechanical. So I'll just plow on. So now, I mean, we must be getting close to having this file passing, basically. Oh, interesting. We haven't seen this low date signed before. I'll just implement that one for now. I'm sure there are other, I'm sure this 8 can be a 16 or a 32 or whatever, but let's just roll with it for now. So again, this is going to be the same thing again. This instruction is never going to execute. We just branch away before it has a chance to execute. So, I mean, I assume that's what's going to happen. So, do I already have some kind of load? i32.load, i32.store. Yeah, I mean, look, there's a huge amount of duplication there. I'm going to sneak it in here. No. i64 load. Let's sneak it in here. i64.load 8 underscore s. Is that right? Yes. Now, I think this is increasingly clearly something that needs to have a regular expression rather than this huge long pattern. But let me just squeeze this in for now and we'll see what happens. So that should successfully unfold that instruction. Yes. And now we can't parse it. So how does this currently work? Oh, thank you, Marco. You're right. My fingers automatically typed if. Thank you. Well spotted. See, that's exactly the sort of thing that I overlook. Wow, you're really paying attention. Gold star for actually reading the nonsense I'm typing. Certainly more diligently than I am. Okay, so yes. So what actually happens to this though? Like, what do we have a single? Yeah, we do. See, I don't really want to add another AST node called load AS. What I want, so I think I am actually going to have a little look at how these instructions work, so that I can parameterize the load in whatever way is necessary. So this can be 8 or 16 or 32, which is which was exactly my hypothesis. Same goes for store. So I assume that the default, if you don't say anything, it's like the same, you're loading the same number of bits as the type that you're loading into. So this is like into a 32-bit integer, load a 32-bit integer from the memory. Whereas here it's saying into a 32-bit integer, load an 8-bit signed integer from memory or unsigned, 16-bit signed or unsigned, 8-bit signed or unsigned, 16-bit signed or unsigned, and then this is a 64-bit integer, load a 32-bit signed or unsigned integer. So they all have, load is really parameterized on how many bits and whether it's signed or unsigned. It's only just occurred to me, well, hold on, what's going on here? These are all the integer float. But the floats don't have that. It's only integer loads that have it. Which makes sense. Does it? Why couldn't I into a 64-bit float load a 32-bit float from memory? Why is there no F64 load 32? I don't know, but there doesn't appear to be one, which is fine by me. I just assume that would exist. But okay. So for all of these, memory is accessed with load and store. Memory. Integer loads and stores can optionally specify a storage size that is smaller than the bit width of the respective value type. In the case of loads, a sign extension mode is then required to select appropriate behavior. So I'm not really going to care about this, but this does give me some words to talk about it. Storage size is one of the properties of loads and stores. So let me stash that for a minute. Let's make storage size part of those instructions. So I want this to take a storage size. And I suppose I should do store at the same time. And they also have a sign extension mode. Yeah. I mean, that's sort of annoying to represent, isn't it? See, the reason I'm hesitating here is because at the moment, the way that I deal with this sort of large amount of variation is like here. I just have this operation field where I don't parse the name of the operation. I just jam it into here. So actually, maybe I'll do that for now. Firstly, because it's easy. In fact, what I've written here isn't right, is it? I didn't pay attention to what this hash is doing. This is just choosing the receiver of new. So right now we're passing in type, bits, and offset. But we also need to provide arguably the operation, which right now is just going to be load or store. Oh, do I want to do it this way? I am going to do it this way because it's consistent with what I do down here. So, I mean, ultimately, if I change my mind about this and I want to be able to, I want the abstract syntax to contain a more structured representation of these, because these have all, as you can see, all of these numeric instructions have got all these like suffixes that say whether it's signed or unsigned, and in some cases whether it's 32-bit or 64-bit or 8-bit or whatever. And that's exactly what's going on here. So I think what I'm going to do, I mean, right now, it can only be the literal strings load or store. But I'm going to... Maybe this isn't necessary. Because right now this instruction isn't going to execute. So if this is what I'm intending to do, if I was just going to stick the operation in, then I'll just do that when I need it. And I don't need it yet. So I think actually I'm going to back out of what I was trying to do there and just say I'm just going to add i64 load AS here. And then for now, in fact, yeah, I'm literally gonna, I know this is, I'm being very intentionally blunt here, but I'm just gonna try and do the minimum change, which is to make this pattern match the specific string load AS in addition to just load. And I'm also going to allow this to map that instruction onto load as well. So this is like a clue for future me that at the moment we're throwing away information here, that you can see that although we can separately match load and load AS, that information doesn't go anywhere. And if I want it to go somewhere, either I have to parse the A and the underscore S out of the operation name here, or I'm going to need to store the operation on the node so that I can then take it apart in the interpreter, which is exactly how all of these operations work. And arguably they shouldn't work like that, but if I'm going to do a wholesale change that involves moving that work into the AST parser, I'll do that for this as well. I don't want to have one foot in one world and another foot in another world simultaneously, because then I'm just going to get confused about where I think I've got to. So let's see whether that has done anything. Yeah, it has. So now we've got as store n address. Why did I just not manage to copy that successfully? What is going on? Okay, so that's store 8, store 16. Okay, so I'm gonna need store 8 and store 16. So I think I'll probably do those together because it's going to be very mundane otherwise. In fact, why don't I batch all of these together, because they're all more or less the same thing. Right, so with the store instructions, you don't have to specify whether it's signed or unsigned, because it's unsigned. because the internal representation is unsigned. So it's only when you're loading stuff out that you have to explain whether to interpret it as signed or unsigned. And in fact, I'm not, off the top of my head, I don't actually know I don't know what I'm talking about. Why does that even matter? It says to select appropriate behavior. Execution. Memory instructions. Who cares if it's signed? So load and load n underscore sx. If n and sx are part of the instruction, then let n be the integer for which bytes n equals b star. Let c be the result of computing extend. Okay, right. So we're just delegating to this extend instruction. Okay, yes. All right. Yes. That makes sense. If it's assigned, if we're trying to load a signed 8-bit integer into a 32-bit integer, we have to use extend into a 32-bit number, and we have to use the signed version of that so that it knows not to just pad it with zeros. It actually has to interpret it as a 2's complement number, and effectively you have to make sure that the sign bit in that 32-bit number is set appropriately, rather than just one of the lower bits that used to be the sign bit when it was an 8-bit number. So that makes sense. When you're yeah, inherently what you're doing is extending the number to fill more bits, and when you do that, you need to know whether you're supposed to be handling the sign bit or not. So that makes sense. Not just the sign bit, actually, but the whole representation. Is it a 2's complement representation or not? So yeah, I mean, at some point I'm going to get sick of having all of these written down separately, and I'm going to want a regular expression to deal with it. But like I said, I'm being sort of deliberately clunky here as a message to myself later. Okay, memory grow. I mean, it's time for a commit, but let's just see. I mean, look, we're very close to the end now. And actually, I would hope that all of these nested blocks, nested BRs of various kinds, I would really hope that we already support that. But let's see. Yeah, this is just, we need to support, or we need to parse memory.grow. So I will commit what I've got, because I think these are all of a piece. Oh, I was briefly confused about why this was working, and the answer is because this isn't doing anything. Because that particular load, the only reason this case is here is for the optional offset. But actually, I think I should be consistent in, even though it's not required here, like ordinarily I would have been reminded that I forgot to do that because unfolding would have failed, or rather unfolding would have caused parsing to fail. But actually this is not being used at the moment. But I will put in the instructions that we actually need. So it was the store ends specifically. I32 store 8, I64 store 16. So again, I'll put these near to their friends. Where's I32 store? Oh, there it is. It's wrapped. That's why I couldn't see it. I32 store 8. I32 store 16. But like I said, this is not actually... Oh, it's I64 store 16. Is that it? I32 store 8, I64 store 16. Yes. So like I say, this is not... These aren't being used here in this example, but I think it's important that I keep this sort of catalog of what I think all the different load and store instructions are, because they can all take a static offset. So it's important that they get that support in future. The reason it was working before, the reason it's working is because it's actually falling through to this case, which is just the generic, how to generically unfold any opcode that doesn't actually have any immediate arguments, which load and store don't. They just get all of their arguments off the stack. He says, yes, that is true. Unless they have this optional, offset, which I suppose is a kind of abbreviation. So I'm sort of dealing with that here, I suppose. Do I deal with that in the... I must be dealing with that in this. Hold on, what am I talking about? I must be dealing with that further down this file. Yes. Okay. So, yeah, same deal. The unfolding just preserves the presence or absence of the static offset, and then we deal with the sort of... We deal with that abbreviation here by making a default for it. Oh, could I do something similar? Sorry, I'm just thinking about the code that I wrote. No, not really. Okay, anyway, I think I've squeezed all the juice out of this that I can. Okay, well, so just for the sake of consistency, I'll say parse the i64. Oh no, this is unfold. Unfold the i64 load 8s, i32 store 8, and i64 store 16 instructions. These are the only 3 we need to make br.wast parse. So for now, I'm avoiding the larger problem of how to support all possible I can't remember what I called it. Widths of some kind. Memory instructions. Oh, it would have been in here, wouldn't it? Memory instructions. Storage sizes and sign extension modes. Maybe I can link to this. And then this is just going to be parse. At the moment, we're throwing away the storage size and sign extension mode. Because the test in question, because the test we're working on, br.wast, doesn't even try to evaluate these instructions. So it's good enough to be able to successfully parse them into a load or store instruction. In future, we'll need to actually remember the details of how many bits to read or write and whether to interpret the reads as signed or unsigned numbers for the purposes of padding them out to a larger number of bits. Let's separate this out because it's getting a bit lengthy. We'll cross that bridge when we come to it, but I imagine I'll just store the operation on the AST node in the same way as I do for, e.g., binop. Is that what it's called? Oh, unary op and binary op. At some point, we should parse all of these meaningful instruction names in the AST parser, but that should be a change that affects all such instructions, not done piecemeal. Okay. So yeah, now we just need this memory.grow, which apparently is being unfolded successfully because it's not special. It doesn't have any immediate arguments. It's being unfolded in the default way. We just have to be able to parse it. So maybe here. How much of the stack does memory.grow consume? Memory grows memory by a given delta and returns the previous size. So let's give it an argument called delta. Well, in fact, that's just what happens at runtime, right? So at this point, we just need to... Oh, why am I doing this? We already support this. Here they are. So these are all the instructions that are nullery. They don't take any immediate arguments at all. Not even optional ones. So this can just be memory grow equals data.define, because that is currently and probably forever nullery. All right, it's not impossible that when I run this, all the tests are going to pass. So let's see what happens. Well, close. Okay, more stuff passed. So let's just say pass the memory.grow instruction. I don't think there's anything interesting to say about that. Okay, what's this nested block value? I'm mildly annoyed that that hasn't just worked. And it's more of this nonsense around the stack not being empty when it should be. So in a way, I'm glad that I put this assertion in so that I'm finding out about all this stuff. But in another way, it's actually rather annoying, because if that's the only problem, then the test could be, you know, I could be celebrating a passing test. Oh, yes. Well, this was something that I was concerned about before, that I'm not sure that this is actually a valid constraint, because it should be, you should be allowed to invoke a function. You know, if a function takes 2 arguments, you should be able to invoke it, and the function should pop 2 arguments off the stack. And actually, I don't think it is correct to assert that the stack should be empty at that point, because why should it be? You might be halfway through evaluating a deeply nested arithmetic expression that involves lots of function calls, and the stack is being used to accumulate the results of those expressions. So it's really none of your business whether there's anything on the stack. So this assertion has been useful up until now because, well, it was only recently that I added the ability to use the call instruction, and all function invocations were being done from the top level, in which case it was true that the stack should be empty at this point. But I think that in general, that is not a valid thing for me to be checking. So I'm going to remove that. Yes. There we go. The call was coming from inside the house. It was me having a dud assertion that was making that test fail. So let's say remove empty stack assertion from invoke function. So let's say this was correct when we could only invoke functions from the top level, i.e. an invoke action in the test script. But now that the call instruction also uses invoke instruction, invoke function, we need to support situations where evaluation is halfway through computing some intermediate result, and therefore does have extraneous operands on the stack. It is not true in general that the stack should be empty after the function's arguments have been popped. Okay. Well, let's say it is no longer true in general. Because that did used to be true, but it has stopped being so. Okay, and of course I have to move BR out of pending and into parsing. So actually I think, well, let me run the tests, but I think that I think that's what that commit is gonna be. I'm gonna need to move it over. It's looking pretty hopeful so far. So in some ways that was ideal because it allowed me to make progress and make a new test pass without having to do very much work. However, it hasn't really functioned in the way that I wanted it to, which was as a sort of forcing function for me to make call indirect and global and table actually do something. But I have made incremental progress towards that because I've hooked them up in the parser and they've got AST nodes now. So we're closer to being able to evaluate those, but not very close because we can't actually evaluate them. So I think that needs to go in the previous commit because now that test is passing. Okay, well, let's speculatively, just for now, let's speculatively revisit this list because now this BR is done. Now, what situation is BR if in? Oh, interesting. So this is complaining about some control flow property. I mean, it may need those, but there's a different problem here. Control flow problem. BR table. Ooh, that comes very close to passing, doesn't it? Control flow problem. Data WAST seems like it needs a lot of stuff that we just don't have yet. Oh, these things are just a long way off from being supported. Yeah, whatever. That's some other instruction I don't support yet. If.wast. Oh. So this actually, this if.wast, which is initially what we were looking at, that drove us to this. So this was previously failing because it couldn't parse the call indirect, and now it's failing because it can't evaluate call indirect. So that's moved infinitesimally closer to parsing, but not very much. Labels, I think, is going to be another one that we just haven't thought about yet. Oh, I'm wrong. Great, that's good news. I mean, I haven't thought about it, but it's just passing. Add labels.wast to passing tests. I haven't even looked at this, but I think it wasn't passing before, and now it is. Great. Cool. Goodbye, my friend. I suspect that load.wast is not going to be very cooperative because we haven't implemented any of those funky... Oh, in fact, that's actually trying to call indirect, so that's basically still true. I expect loop is going to be the same. Yes, it's trying to actually call indirect. So yeah, I think it's clear what I need to do next. mem size I haven't implemented. Wow. Okay. Return.wast also passing. So actually, somehow, incomprehensibly, at some point, these have started passing, and this makes me wish that I'd had the thing that Chris Zeta suggested, which was actually a sort of silent list of things that I thought were pending that could just run silently and not produce any output, but still tell me when they started passing, because I feel like I've missed the moment when these tests started working. So really, maybe I should just amend this and say add labels.wast and return.wast. What have I completely failed to actually include that in the commit. I amended the message, but I didn't. Okay. So return.wast is gone. Let's try select, which I am sort of hopeful about. Well, that's hubris, isn't it? So this indicates that there's actually an instruction in here that it hasn't been able to even parse correctly. It hasn't unfolded correctly. So let's just briefly see what that is, because maybe it's something simple. Oh, is this simply that select can take a whatever this is, a type? Let's just look at that very briefly, because I think that might be easy. So it's this sort of business, you know, an optional type. So we currently don't have any special handling for select here, but I think we need it. So when we're unfolding, and I'm sure that this is true of a lot of other instructions and I just haven't dealt with them yet. So when we're unfolding, we need to be able to optionally pull out that type. And then this becomes flat map, opcode, type, compact. And then that's going to fix that unfolding error. And now we don't have support in the parser for the fact that select can have a type after it. So in the parser, we need to say, like at the moment, how does select get parsed? Right, at the moment it just gets parsed by this thing, which is where all the simple stuff lives. I think we're going to need to add something vaguely like that down here. And unfortunately remove select from there and give it some special handling. So this is still going to be select.new. Does anyone care about the type yet? I don't think they do. I think we just need to do this. but not that, because this is, sorry, this is assuming rest. So this needs to be if peak in result read. Like no one cares. So do we have something? So how do we deal with that for block? Right, it's that, isn't it? If peak in result star, then read through to, yeah, that's fine. That's the same as what we're doing here. I don't think anyone cares yet. So I think that's gonna fix the parsing of it. Func. Select func ref. Okay, well that turned out to not be the only problem. Func. Ref null func. Ref null func. Parse normal instruction func. Right, well I guess these are getting unfolded, aren't they? So func is the first thing that it's seeing. I'm just trying to work out if this, I didn't intend to be working on this. For example, is this call actually going to do something? It does rather look like it is going to, because this select isn't a branch. So I think this probably is going to try and do a call indirect. So I think I'm chasing my tail a bit here. I think, this change I just made was worthwhile, but I'm not gonna try to get that whole thing working. It's like it was worth making this change because this was simple. So this is unfold the select instruction. We need to pay attention to the optional type. Well, let's say result type. Account for optional result type when parsing select, because we already did parse it, and I know we already unfolded it, but let's just use this as the previous commit message. Okay, fine. So I made some progress on this, but this table call indirect global ref.null func. There was some other ref.extern. So that one actually looks quite unappealing, doesn't it? See, I don't think this needs BR anymore because I've implemented that, but so I am sort of interested in this. What is this control flow problem for BR if? I think that seems worth investigating. Yeah, because the reason this feels worth investigating now is because this is related to what I changed earlier. So while that stuff is swapped into my brain, it's probably worth digging into it, because otherwise I'll just have to remember all of this stuff again later. So this is saying uncaught throw. So let's see, as loop last in BR if. So this says loop, call dummy. Okay, so this is a folded loop. So that means this is the body of the loop. So the series of instructions are first call dummy, which I think is an empty function. Yeah, so that function doesn't have a body. So that's easy. That doesn't have to do anything. The problem is coming when we call it with 1. So first we call it with 0, and apparently that's fine. So when we call this with 0, we'll call dummy. We will pull out the first argument, which is 0, and then we'll say conditionally branch O, conditionally branch to block 1, which is implicitly, well, it's the block that is induced by the body of the function. So this is the same thing as with return, that we need to unify the explicit structured instructions that are block, loop, and if with the sort of implicit structured instruction, which is this is the body of a function. Because that's what's going wrong here, is when it tries to branch to block 1, this loop is block 0, and then when it tries to look outside it, it's like, well, there is no block, loop, or if around this, but we need to support the situation, and I'm sure the operational semantics say that when you start executing a function, you should push a label onto the block. You push a label onto the stack to indicate that you've entered a new scope or block or whatever you want to call it. So we're not trying to do that at the moment. Now, what I want to know is, can I just make that magically work with my as structured instruction helper, which now seems less accurately named if I'm going to use it for something like this. Oh, no, I didn't call it that. I've just remembered. I didn't call it that. I called it as branch target. And that is exactly, so this is why choosing a sort of functional name like that describes what it's doing rather than where it's used is going to pay off as branch target. So is it possible for me inside invoke? So how does as branch target work? You have to provide a label. You have to provide an arity. What's the label for? Oh, the label is optional because that's only used in the case where the branch is using an ID rather than a number. And that's a temporary state of affairs, because once we've introduced the identifier context, they'll all be numbers. So I think we can just pass in a label of nil, and then the arity is going to be whatever the result type of the function is, which is something that we already needed to know to make return work. So actually, we might be able to unify these. All we need in order to well, no. Let's get this working first. But I can see that we're going to be able to unify these, which is very exciting. How does return work at the moment? Throw return, right. Okay, all right. And then where do we catch return? Inside invoke function. Yeah, of course. So with current function is used to update what function is the current one. And then I think I want to say as branch target. Well, let's do it this way around. So as branch target nil, arity function results length. So yeah, the results here is just comes off the function object. So I think if we, so now we're doubling up. You know, catch return is dealing with the return instruction, and as branch target is dealing with branch instructions. And that's what I meant when I said we should be able to unify this. But we just need a way to be able to get the return instruction to be able to trigger the handler that we have inside as branch target. And I mean, this is one way of doing it, is by having it throw a different tag entirely. And that should work for now. Well, let's see what happens with the test. Right, so a lot more of it has passed now. So that has, I think, comprehensively solved that problem. Now we've got a different problem that we're trying to evaluate global set. Okay, so this control flow problem question mark has gone away. Let's just see what the deal is with BR table. It's presumably very similar. Wow, something else has gone wrong there, and it seems like it's going to be some kind of extern ref related problem. I realize I'm jumping around here, but I'm trying to build up a bit more of a holistic picture of what is blocking me on all of these fronts. Like, what is the most impactful thing that I could work on next to be able to get the maximum number of tests running? And to understand that, I need to know, like, what's blocking me from making progress here. So what's the problem here? This all looks like stuff I should be able to support. One, is it somehow failing to parse that? Where's the one coming from? Okay, I'm getting ahead of myself. Let's deal with what we were looking at here. So this is treat function body as branch target, or execute function body as branch target. So this is this allows normal branch instructions, e.g. BR, to branch, to target the function body rather than an explicit structured instruction, i.e. block, loop, or if. We should be able to, this is essentially all that return does, so we should be able to unify the two in the next commit. Unify the two mechanisms. So if I get rid of the catch return, so the only problem here is that we don't know how large a number, well, and it has to actually be exactly the right size of number, because what I don't want is for this to just be able to catch an arbitrarily large number. I want it to be able to I want to keep using. I don't want bugs to disappear. If that index is out of bounds, I still want that to result in an error. So either we need a special value, you know, inside here, when we look at the value that we get, the payload of the throw, maybe this should be payload. Well, it's the result of the block. That's why it's called result, because it could be did not throw. But once we've got the payload, it's only the integer case I'm worried about here. I don't care about the string because that's dead to me. If there's a bug and a branch is trying to branch to index 5,000 and there aren't 5,000 nested blocks inside the function body, but that's really something for validation to take care of, isn't it? So what I'm thinking about here is how do we make return work within this framework? And I mean, the way it currently works is not unacceptable. And in fact, maybe this is the least worst option. Maybe this is the tidiest way to achieve it, because otherwise I have to come up with some mechanism for making it possible to essentially do a branch that is specifically targeting the function body. And the problem is that I don't know easily what the right index for that branch is. If I'm executing some branch instruction, or if I'm executing, it's specifically return, right? If I'm executing some return instruction and internally I want to implement that as the same as a branch, like throw the tag branch and then as a payload to that, provide an integer that says how many nested structured instructions or how many nested branch targets you want to hop over before your branch reaches its target. I don't actually know at that point what the value of that number should be. And of course you can figure it out by looking at the AST, but I don't really want to. So maybe this is the easiest way of doing it, of just every time we invoke a function, there's a new catch handler wrapped around the execution of the body that allows return specifically to just bust straight out of it with a different mechanism. I mean, it's still the same. It's still catch and throw. It's just like a different encoding of the thing that we want to happen. But maybe that's fine, because otherwise I'm going to come up with something silly like, you throw branch, but your index is -1. And then we would need to know inside as branch target, we would need to, at the moment, this doesn't know that it's constituting a function body rather than anything else. And so whatever the special encoding is for, I actually want to return to the enclosing function body, not one of the structured instructions, this thing is going to need to take another argument to tell it that that's what we want to happen. Oh, but you see, the only unfortunate thing is The unfortunate thing is the stack unwinding, because at the moment the implementation in return is not right. So I mean, obviously I could make it right, but the annoying thing is that I've got the right implementation of it in this as branch target. So really I would like to share this code with return. I mean, maybe I can do that by extracting, because it's really just these 3 lines of code. And, well, this one. But that's the problem, right? It's the interplay between do this before you yield and then do this after you've yielded. That is the protocol for unwinding the stack. And at the moment, if I just pull this out, that's only half of the story. Like, you need this wrapper around it. I think I need to think about this a little bit more. So actually the current implementation I think is fine, apart from the fact that this code is wrong. But I think I need to, I'm getting a bit sleepy. I think this is something where I need to come back. This isn't an entirely mechanical transformation. This is going to involve a little bit of design in making sure that whatever the Lego pieces are that we use to build up the return handler and the branch handler, I want them to be constructed out of the same general purpose pieces, but I want them to do slightly different things depending on whether it was a return or a branch. Or rather, I need the target. I need to be able to reach the function body as a sort of special target. I wonder whether it's possible to move the... No, I can't move it into here because you only want the return handling when it is a function body, not every time. Okay, I'm just going to back away from it for now because, like I said, I think I'm a little bit too tired to actually think straight about that. In principle, we can unify the 2 mechanisms and therefore share all the logic about stack unwinding, which is currently not implemented correctly for return, even though it works for BR and so on. But at the moment, I can't see an elegant way of doing that. I'll come back to it. This works for now. I'll come back to it. I don't want to say it works for now because return does not work properly. Okay, so that got me to this point. Maybe it's time to think about global set then, given that I've got a test that this one is not, because I find globals less intimidating than the... I don't think call indirect is going to be difficult actually, but I think globals are easier. So this is BR if, yes. So this declares a global and this sets a global. So it feels like this should be very similar to... Oh, this doesn't only declare it, it initializes it, I assume. Well, let's do that then. So I think, although this isn't what's causing the test to fail, I think I want to think about how to make global work here. So let's pull that out as like a thing that we're actually serious about trying to implement. Global. I mean, what do I call these things? Name. That's what it says down here in invoke. Global name and then value. Oh, sorry, I'm looking at the wrong thing. Oh, this is okay. All right, let's just look at the. This looks like a type. Let's just ignore that. The reason I'm being specific about this is because I want it to fail fast. As we discover different patterns that can appear here, I want to know about it. So let's say global name, type, value. Let's say that's what that looks like. And then in here, why don't I just say globals? I mean, I realize the irony that I'm making this a piece of effectively global state, and at the moment we've got locals threaded through evaluation as a hash somewhat unnecessarily, but that's fine, we'll survive. So let's say self.globals, and I'll put these in a hash. Or do I want to do that? Oh yeah, locals is a hash. Locals is a hash. Oh no, it's not. Right. And the reason it's not is because we need to be able to index into it with an integer as well as a... Why did I make that change? Why couldn't I just use a hash? I don't know. I don't know why I couldn't just use a hash. How strange. Oh, because names are optional. That's why. That's why. Yeah, okay. So if the... Okay. Thank you, commit message. Right, I now realize that storing the locals in a hash is not going to work in general because it's possible for some or all of them to be anonymous. Right. So, and that must be true of globals as well. I think everything turns into an index, eventually, doesn't it? But at the moment, because I don't have my identifier context, I have to support both. I have to support globals with names and globals without names. And so I can't keep them in a hash keyed on name because some of them might not have names. And so I'm going to have to put them in this silly... association list thing. Okay, well that's depressing, but understandable. Okay, so when there's a new global here, what we want to do is push it onto the list. And we know what the value of it is. I mean, what we have to do is say value equals evaluate value with no locals. And then we're going to say globals gets pushed onto it, this thing, name, comma, value. So I hope that error in evaluate instruction i32.const, no matching pattern error. Oh, I suspect that this needs to be an expression. So that's a that's a list of... Oh, no. Oh, it's worse than that, isn't it? I have to put it through the AST parser. What am I doing? I can't just jam an S expression straight into evaluate. That's just a type error. Parse, I mean, obviously this is ridiculous. I shouldn't be in this situation in the first place, but, you know, it's because I've got this weird Frankenstein's monster of none of this stuff is supported by the AST parser yet, so I'm having to ram the two things together and they don't really fit, and I'm just having to like make them fit. And this is the cost of that, is that it's a big transporter accident where they're just sort of interpenetrating each other and they just have to deal with it. Okay, unhandled exception. I was not expecting that. Why should that happen? Well, the reason is because I've forgotten how evaluate works. And that is a bad thing to do when you're trying to evaluate something. Because, of course, evaluate does not return a value. It pushes it onto the stack. So we have to do... First, we evaluate to get a side effect, and then we pop the stack into value. And then we can append that onto globals, I think. Right. Okay, so that has not broken anything. I'm going to carry on rather than commit this because I want to wait until it works. And I've got no way of knowing if it works yet because I haven't implemented it's not implemented in the interpreter, sorry. So I guess there was local get, local set, local t. What is it we want here? Global set. I mean, this is a classic example of a place where it actually doesn't matter because I don't think anyone is going to check the value of this global. So I suspect that if I just do in global set, you know, stack.pop 1 goes into value, I can probably just leave it at that. Let's try and make this consistent. Yeah, see, that's fine. So I actually didn't need that other global stuff. So I'm not going to add it. So I'm glad I didn't commit it. So this probably needs a comment, you know, to do store the value in the global. But this is the only change that's necessary to make that test pass. So that's very exciting. And is BR in a... Oh, we've already done BR. It was BR table that we haven't done. Oh no, that's more complicated. Okay. Okay. So let's say begin implementing the global set instruction. This doesn't, actually do anything with the value yet, but that's sufficient to get the BR if. And so that means that we're going to need to add this to the test script. Looking good so far. Haven't broken anything else. That's a relief. All right. Well, okay. Well, let's add that. So I don't really want to lose this work. In fact, I made a big assumption there that this was all fine, but I think it is. Yes. Oh, well, I must have checked that. Well, maybe I didn't, but it's independent of that stuff. So it feels like I've got two choices at this point. I could go back to... Well, effectively, I can try and make one of these call things work, whether it's call indirect or call. Because it might be that the support for recursion is as simple as just getting my act together with the stack unwinding. And I sort of suspect that that is the case. Or I could keep pulling on this globals thread. So, like, what is the globals situation? Let's just run it and see what happens. Nothing good. Oh, this, yes, I'm sorry. I forgot. This is the one with the nested comments. And how intimidating is it aside from the nested comments? Oh, I understand. So these nested comments are here to have an in. Okay, yeah, I misunderstood these before. I thought that this was something that was temporarily commented out, but it's not. It's an inline comment to show you that because this doesn't have a name, it's implicitly global number 3, global number 4. So these are the indexes of the globals, which should have been obvious to me when I looked at this before, but I wasn't really paying attention. This looks a little bit gnarly to me, if I'm honest. It's got this import, which I'd rather not deal with. Global import spec test I32. What could spec test mean? There's not a file in here called that. So I'm gonna park it and have a look at call. I think I am going to commit this, even though it's sort of floating free, really. Because if I stash it, I'll forget that I've done it. And I think it's correct, and it's harmless. Oh, I've realized I should have removed global from the... Oh. I don't need to... In fact, I don't want to double up on my pattern there. So let's say initialize global variables during test script. I thought I'd need this to get brif.wast passing, but it turns out that test only requires a dummy implementation of global.set, i.e. it never actually reads the value out again with presumably global.get. So I didn't actually need, so I didn't need to. So it's not yet necessary to remember any of the values of globals. But I think this change is correct and useful, so I'm adding it now so that it's there when I do inevitably need it, even though that time is not now. Okay, so that's a little bit of a risk because I'm adding code essentially for no reason, but the reason is I wrote it and I think it's right, so I'm just gonna let it I'm just gonna let it continue to live. So let's look at call then, because again I've had my head in the call stack and the operand stack unwinding, so I think it would be helpful to just keep that momentum going rather than let this continue to fester. So unhandled exception. So this is where we invoke fac. So it works with an input of 0, which I assume is the base case for factorial. You know, if I was going to write factorial recursively, I would say def fac equals fac of n equals, you know, if n is 0, then 1, else n times fac of n minus 1. So fac of 0. Oh, double question mark. Okay, so fac of 0 is 1, fac of 1 is 1, fac of 2 is 2, 3 is 6, 10 is some massive number, 20 is some even more massive number, and as you can see, this function grows quite quickly. But, you know, Ruby is impressively, well, I suppose it's not that impressive how fast it is because it's only a linear number of operations, but the fact that the output can grow so large is actually quite sweet. So that's what I would do, and that's probably what this definition of fact that we're about to look at does. So it makes sense that this one doesn't need to do any recursion because on an input of 0, it's just going to immediately return 1, which it does. Well, it eventually returns 1 somehow. On an input of 1, even though the answer is still 1, I would expect that to be computed by multiplying 1 by the factorial of 0. So this one has actually got a slightly different data flow genesis in that it comes from a multiplication, whereas this one, it's just a literal 1 that's being returned by the recursive function. So I think it's the fact that we've been able to get this far through this file with all of these function calls, and then we've fallen over as soon as it comes to factorial, which is in the recursion section, is extremely suspicious. So this doesn't actually use return. So there goes that theory. So what is wrong? Is it another one of my overzealous assertions that is actually checking something that's not true? Or is it something else? So it's line 296. We're getting an overzealous assertion. Oh. Oh. It's nothing to do with the call stack. It's to do with this syntax. So it appears that, and we haven't seen this before, presumably that's because we haven't needed a function to call itself before, that when you define a function, you can give it sort of two names. So this reminds me a little bit of the difference between like let and let rec in like an ML style language, where it's like let rec is where you say, I want to define a recursive function and I'm giving it a name so that it can refer to itself. So I don't think that's exactly what's going on here, but it does feel a little bit like the reason why this feature exists is because this name is not visible inside the function. I mean, I'm a little bit confused because we do have this, we're already using this. So we already support this style of name. It's just that I don't think we've ever been in a situation where we've had both this sort of local name and this exported name together. And I mean, I think the problem here is that they conflict with each other. So we have to understand, because down here we invoke it as fac. So in some sense, that is its name. In just as much as when we were invoking those. Well, in fact, where do we invoke those other functions? Oh, it says auxiliary definition. So maybe it's actually not possible to invoke these from... Maybe it's only these call instructions that can call these. It's not the... Maybe... Sorry. I'm just talking gibberish. Maybe we need to maintain two separate maps of names. Maybe these exports are what is visible from outside the module, because that's what export usually means. And I just haven't had to engage with this before. I've just been somewhat mindlessly yanking these strings out and using them to refer to the functions. But this is starting to look like the name that you give a function here directly after func without saying export is like a module local name, and you can use call inside the module to call that thing. And then the exports, I mean, I don't really know how modules talk to each other, but I haven't seen that yet. What I can see is all of these calls to these functions, which all use their exported names. So what do I want to do about this? Do I just want to separate these? Because at the moment, there's a sort of wrong-headed notion of a function having an intrinsic name. And I think maybe that's, as you might have guessed by my choice of the word wrong-headed, I think that might not be entirely correct. I think it might be better to think of a function as a bundle of all this other metadata, so the parameters and the result types and the... what's locals for? Like, we can declare locals, I guess. I guess that's something I've already forgotten, but I guess in a function definition you can say there are some local variables, whatever. Yeah, that makes sense. Okay, yes, you can. You can say, I want there to be some local variables and here are their names. So that's fine. That's allowed. It'll probably go away when I do this mythical identifier context. But for now, it lives here. And the body. So if we think about a function as being more of a bundle of those things, because at the moment, we just have a list of functions here. And we iterate through that list to find functions, to find the function with that name. But maybe that's not right. Maybe what we need to do is to have like hashes of that map exported names onto function definitions and also internal names onto function definitions. And I'm not sure how to talk about those things. So I'm going to have a look at the documentation, not... Excuse me. Time for sleep. Not so much to find out how it's supposed to work, because I think my guess is probably okay. So, but more to find names for things is what I want. Function definitions can bind a symbolic function identifier. So that's straightforwardly what this is. This is the function identifier. That sort of is part of the function. Functions can be defined as imports or exports inline. And the name is a string, right? The syntax for exports mirrors their abstract syntax directly. Exports can be specified inline. So export, yeah, function name. What? Function index. I don't understand that. I don't understand how this works, but I'm just going to ignore that for now because we're dealing with this inline case. So when it's inline, you say export. Okay, so that's saying that's equivalent to saying export name. Oh, okay, and then you have to specify the function you're talking about. Right. Right. So in a module, you can have a standalone export statement that just says export as foo, the function $foo, and then later on, or I guess here it's suggesting immediately afterwards, you have to say function foo is this. So how does everything work at the moment? How do functions get their names? I know that sounds like something that the person who wrote this software should know, but I actually can't remember. So it's going to be in define function somewhere. So this just shovels everything into define function. So what does it do when it finds... Ah, this is what it do. Okay, right. That explains it. Right, so there are two different ways that a function can get its name right now, and they're conflated. So one of them is this function identifier. And one of them is its exported name. So, I mean, I guess the easiest way for me to do this at the moment, and I think this is what I'm going to do because I'm lazy, is give it a name and an exported name. and this is initially nil, and this one will automatically be nil if one wasn't provided. But then this export here, we're going to set exported name. Like that. So this is a hack, but so not only does it have a name, it also has an exported name. And I'll tidy this up at some point, but right now this is the cheapest way to get what we want, which is to have a function that can have two names. And I don't know if there's any constraint that maybe you're allowed to export the same function under multiple names. So like this is not a principled way of doing it, but it's going to get us over this hump, I think. So so basically we're segregating. Previously it just so happened to work that we could smush all of these things together, and all of the functions that got an exported name were only ever called from here, I guess, in invoke or assert return. So all of the exported names were only addressed in these test script actions. And then when we did call, this was actually only ever checking the function identifier. So this was sort of all working out. But now we're going to separate those concerns and say that this is actually looking for exported name, and this is actually looking for exported name. And so given that segregation, we should now, this is, the problem is that that Factorial's name was being clobbered. That it was being initialized to be $fac, and then it was being clobbered by quotes fac. And yeah, I've got a to-do list item, which is actually interpret these strings so that they don't literally include the quotes. But right now I'm just using in both cases, I'm just using the raw atom from the S expression, which in this case is the 4-character string $FAC. And in this case is the 5-character string double quote FAC double quote. But because they're just identifiers, that doesn't matter other than that it offends me aesthetically. Okay. Assert exhaustion. Okay, so this was trying to assert, and that was quite slow, it sat there for a while, didn't it? That was trying to assert that the call stack has overflowed. Not overflowed, but, well, we've run out of stack space is what I'm trying to say. So there's obviously some notion of what the maximum stack depth is, the number of nested function invocations that you're allowed. So I guess... In fact, I guess that... I don't know what was slow here. I mean, hold on, let's just have it print out. While it's assert returning. How and where does it print out the... Oh, it's command. All right. Let's just pretty print. Oh, I have to put this. I'm just curious what was slow there. All right, fib of 20 is slow. Okay, well, I mean, that's a little concerning, isn't it? Because it shouldn't take that long to... You saw how quickly Ruby could calculate fib of 20. So I feel a little bit embarrassed about how that throws into stark relief the slowness of this interpreter, but that's okay. That's fine. I intentionally haven't thought about performance. So although it's a little bit of it's a little bit bruising to see how long it takes to compute the fib of 20. I will take that on the chin. So the problem is that we don't support assert exhaustion, and I think that I'm going to deal with that by ignoring it, because we're already ignoring plenty of things. That does feel like something that we could fairly easily implement, but I'm not gonna. Hello, my old friend. Okay, so it's call indirect again. This is gonna kill my test runtime, isn't it? How long does that take? .24 seconds. Feels like much longer. What about if I turn YJIT on, which is one of the things I wanted to investigate? Okay, well that does actually help. It's 2.85 seconds. So it's not, it's not an order of magnitude, but it's half a second faster. Yeah, okay. I mean, that doesn't make me feel very much better. Okay, fine. So what am I doing here? Oh yeah, okay. Store function identifier and exported name separately. These are effectively two separate namespaces. Functions have names inside a module, but they can also used by call, but they can also be exported from that module. Well, let's say functions have identifiers inside a module used by call, but they can also be exported from that module with names used by invoke and assert return. Some functions, e.g. fac in call.last, can have both, so we need to store both to avoid one clobbering the other. Ultimately, these functions should just be stored in a hash rather than knowing their own names. Keyed on name rather than knowing their own names. But this change is simpler and gets the job done for now, which appears to be the spirit of this particular project. Okay. So I've made some little inroads into... Yeah, I mean, it turned out that that wasn't anything to do with return. It was just to do with function names. So today I learned. Now it wants to use call indirect. So what is the least intimidating? Oh yeah, so this is BRF is passing now, right? It all sort of merges together in my mind, but yes, I just forgot to remove that from the list. What do I want to pick on? Yeah, I mean, it really looks like if just wants call indirect. So maybe it's time to return to it. and was call indirect to... I remember I looked at these at the beginning and I found them too intimidating. Let's re-intimidate myself. What's the problem with call now? Like, what should I be worried about here? Oh, yeah, okay, call indirect. Okay, well, is call an easier way into... Oh. I'm a little bit confused by that. Why is it even trying to... If this is as call indirect first... Call indirect type check. Oh, right. Okay, yeah. No, okay, that makes sense. Because this returns, you know, this isn't like a branch that breaks out. It's like, yeah, okay, this is already executed, but now execution is going to continue. Do we have globals in here? Yeah, of course we do. All right, I think maybe this is the least intimidating because it makes light use of call indirect. So let's see. Let's see what we can do. So this is saying so I think maybe we've got the pieces to implement call indirect. Oh, except we're not keeping track of the function table. So what does this look like? Table. So this is the only one in call.wast. So that's good because that means I can do an extremely lightweight implementation of whatever the heck that's supposed to do. I've got too many buffers open. Let me just... I find it impossible to keep it straight in my head what I've got open, so I'll just pare it down to this one. So this one, we're already studiously ignoring this. So let's unignore it. Let's look for table. Well, let's say table funcref. I mean, what does it look like in general? Just so that I know what to call it. Table funcref lm and then some names. That's fine. I can just do that. Let's just do it. lm. What is this? IDs or names? I don't know. We haven't figured that out. So here we want to... Presumably it's possible to have more than one table. Indeed, and that's why when you do a call indirect, you specify a table index. But in this case, there is no table index. While I'm doing this, how do I want this to work? It's a similar... What the heck? It looks like you can add elements to tables after they've been declared. So this looks like it's saying table T3 and then add more to it. This looks like there's a sort of, the name of the table is optional. So why don't I just say, let's assume this is per module. Tables. Self.tables is empty. And then this is just going to push a new table on. That's it. So I'm just going to remember those names. Yeah, I mean, I think that's it. I need to make the table thing. Maybe it's sort of elements. Let's do that. Okay, I mean, who knows if that's what LMs even stands for, but that's what I'm going to call it. So this gives us the ability, where are we at? Okay, I've added tables. I think probably this needs to happen per module. And actually, maybe that's true of globals as well, now that I think about it. How global is a global? It must be global to a module. It can't possibly be global. That's not a thing, is it? Right. Okay, yeah, it's all scoped per module, isn't it? So hold on. When did I do my globals business? Let's change that because I'm pretty sure that's wrong. Well, yeah. It's actually a bit weird that we initialize functions up there, to be honest. I don't see any reason why you would want that to be initialized in that way, but whatever. I think the memory and the stack are sort of properties of the machine, aren't they? Whereas the functions are very much a property of the module. So it doesn't really make sense to me. I mean, is there any problem if I just remove that? Because if there isn't, then I feel more comfortable with that being removed, because I think that's, unless I left it there for a reason that I've forgotten, it doesn't make sense to initialize that, because that is literally the list of functions in the current module. Yeah, I mean, I'm just thinking about exports, but I guess we're in a situation where I don't think I've seen a test that tries to define two different modules and export things from both of them and then invoke those functions into different modules. And I'm sure that's possible, but I haven't seen the test try to do it. Okay, so I am actually going to remove this. Remove initializer for functions attribute. Or let's just say it's not right, is it? Only initialize functions attribute when inside a module. This is a list of function definitions in the current module. So it doesn't make sense to initialize it to anything until we start evaluating a module definition. Okay, that makes me feel a little bit better. Okay, well that's undone that change, so let's just get rid of that. Globals needs to come down here. Again, easier to just make that change again than to actually deal with the merge conflict. So is everything currently working? Yes, it hasn't broken anything. Again, I'm not going to add this just yet because I don't know if it's fit for purpose, but this feels like a prerequisite for calling direct, right? Which, because it is. All right, well, I'll pull my finger out and actually try to implement call indirect. I'm going to do it here next to call. Just getting so sleepy. Table index, type index. I don't think we care at all about the type index. I think we just care about the table index. So that means this is tables, slice, table index. Oh, so it's like name equals, look it up in the table, and let's put name, and then let's exit. Oh, right. Of course. That's finding the table. And then the name is where we go to table elements, slice, whatever came off the stack. So stack.pop 1 into index. Index. All right. Does that do it? $func. All right. And then function equals, and then let's see, function. Boo. Why doesn't that work? You've got a $func. What's your problem? Oh, because this should be name. I mean, this is really a mess, isn't it? The naming of these things is not at all good. Nice. All right, it has found the correct function. So now, I mean, sorry about the delayed gratification here, but we can actually invoke that function. So I think that's the right way to play this. It worked. All right. Memory grow. All right, I think we can get away with making this do nothing. It's just that we need to interpret it and do nothing. Okay, So, exciting times because call indirect is sort of working now, at least in this very simple case. So, create tables, well, let's say function tables when reference tables when evaluating module definitions. These tables are used by call indirect, so we need to populate them before we can implement that instruction. Okay, and now implement the call indirect instruction. Nice. Okay. Now there's a memory grow problem. What does the AST say? Nothing. Does this take an argument? Of course. It's like delta or something. Expected 1 got nil. So what does... Oh, memory grow is supposed to push something onto the stack. Memory grow returns the previous size or -1 if enough memory cannot be allocated. Okay, we've got to push something onto the stack. It's expecting to get 1 back. Do we declare a memory that's 1 page big? Yes. Okay. Push. How does memory work? So it contains some bytes. Maybe it would be nice to have a little accessor on here. So let's say size of bytes.length. Oh, sorry, it's string.byte size. In bytes per page. So here we can say memory dot size in pages. Real seat of the pants stuff here. Oh, why doesn't that work? Maybe I did mean bytes, because that was the, I realized now that that's the argument. So yeah, bytes dot byte size, I think. Yeah, I mean, we are not talking about what the encoding of this string is, so I think better to be explicit about. Oh, I'm still running this inside time. I didn't realize that. Okay, so that fixed that problem, but now we've got another problem. Global set. Right, which is something I haven't implemented yet. Okay, well now it's time to implement globals, isn't it? I think I'm going to roll this into one. Implement the... Oh, Was there no... I thought I had some kind of half-hearted begin implementing the memory.grow instruction. This doesn't actually grow the memory yet, but it does return the size of return the previous size of the memory in pages as required by the test in call.wast. Which one was it? Okay. So it is time to start thinking about globals. Implementing. Oh, I could have just amended that. Okay. Typos in the first line of commit messages are the worst because they live forever. You can never wash out that stain from your Git repo. You can, of course, but once I push these commits up, they're never going to be amended. That's my system for this project. Okay. Wow, my short-term memory is not very good at this time of night. So, right. So that's an unfolding problem. It does not know about global.get. So we will remedy that. Yeah, unfortunately, we're paying a 3-second tax because of that. Okay, parse normal instruction global.get. Where's global.set? Let's just do global.get. I assume this is the same arity as all of these other things, and it works the same way with respect to indexes and so on. So this needs to be get. This needs to be get. In the AST, we need to say get. Yeah, I think I'm just doing this in implementation order at the moment. So now I would hope that we're going to see an evaluation failure. Yeah, don't know how to evaluate that. So let's commit what I've got so far. So as is traditional, let's say unfold the global.get instruction. And then it is parse the global.get instruction, I believe. Let me just double check. Yep. And now we need to evaluate it. Well, I put this one near its friend, so I'm going to do the same thing here. So yeah, I realize now that that one's missing its index. In fact, let's pull this. Well, two things. Let's fix this so that it has the index, because that was just an oversight. Because I was looking at this, but I forgot that actually they have, this is just because of a limitation of Ruby pattern matches that I can't match it in there, but this should have it there. And also, I think I would like to, oops, that was not what I wanted. I think I would just like to pull this forward. Because what's the merge conflict here? Oh, right. We implemented tables first. Now, in this new world. And then here. Here we would leave type and global alone. Oh, that was a bit overexcitable. So this is specifically adding tables. Yeah, well, that's not very good get. Okay, and then yes, this. Now we're tacking globals onto the end. Tacking globals onto the end. Here we're tacking globals onto the end. And we just don't have that anymore. I think that's the end of the conflicts. Okay, have I broken anything very egregiously? It does not look like it. Okay, so no, well, I can manually resolve this. Yes, because it's just about that. Okay, so global get. How does local get work? It's basically that. This is going to be the same. It's just instead of locals, it's going to be globals. Easy. Expected 306 got 10. Presumably that's because we need to implement global set as well. Let's do that. So this is just globals. Oops. 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 And I believe we do not do this because that's just for T. And there doesn't appear to be an equivalent here, or at least I haven't seen it. Okay. Yes. Great. Great, great, great. Okay, what did I do? I implemented global get. Yes, and actually I need to, before I do anything, I need to reword this commit message. We need these to be initialized correctly before we can start getting and setting them. Which is a little bit wishy-washy, but I don't want to, there's no point saying more than that because it's easy. So here it's implement the global.get instruction. And then this is finish implementing the global.set instruction. And now that also incorporates the change to the test script, which moves call into here because it is now working. Did we break anything else in the process, though? That's the question. Looking hopeful. Well, the runtime of this is really becoming quite significant now. All right, nothing's broken. That's great. All right, well, it's irresistible to just try some of these previously problematic ones, right? Because now call is working. Where are we with BR table? Oh, that was the meet extern ref. I'm just going to write that down. Maybe that's not hard to deal with. Depends what that is. It's ref.extern. So this doesn't have a control flow problem anymore. It needs ref.extern. Okay, let's try if.wast. Okay, what's the... This is not complaining about a specific instruction anymore. It's something... Invoke param. No matching pattern error. Parse normal instruction I32. So what's the deal with param? Oh, is it the param type here? Right, that's not something that I've implemented. So this is a conditional that I guess it consumes what's on the top of the stack here and it becomes a local. So here this is getting that local that has been consumed by this. I think all structured instructions probably have to, this is part of the block type, is that structured instructions have the ability to consume stack contents. And then they show up as locals, presumably. That's my guess. So that's something I just haven't looked at yet. So this, I mean, as far as I know, it looks like we've got through. I mean, whatever was blocking it before is no longer blocking it. Now it's worrying about needs block type with parameters. Let's look at these other ones. Load. Yeah, okay, so this needs proper support for load n and store n, which I haven't implemented yet, so that's fair enough. Loop. This looks like another case of block param, but let's find out. So this is a little bit disappointing because I was hoping that more of these were just going to pass, but actually it turns out that there are other things that are not yet implemented. Yeah, look, this loop's got a param. But that being said, this has now refined my understanding of what is missing, right? Like we've whacked some of those moles, and now this is asking me to develop the implementation of structured instructions to be a little bit more, well, to support taking arguments, basically. Memory.wast is just going to be a disaster. Memory.size. I mean, I'm sort of ready to implement that. But it doesn't feel like memory is something that I haven't implemented grow. Mem size. Actually, this is actually pretty brief if I ignore. Yeah, but this is just testing all of the needs, load n and store n. And let's just finish off with select.wast. Am I just forgetting? Oh, this needs a different... Hold on, let's just look at this briefly, because this might be something that I can fix. It needs a different syntax for tables, maybe? Table tab funcref lm dummy. Yes, okay. Let's do this. And then rest goes into this. And then there's this rest in whatever the label thing is. Dollar. A literal dollar. Yes, something like that. Oh, come on. So maybe in keeping with all of the other stuff, maybe the table needs to know its name. Again, it doesn't really. It could just be in a map. Or ultimately, these are going to be able to go in an array once they're all just got an index, but I still haven't, no matter how many times I say that I want to have an identifier context, I apparently don't implement one. So, such is life. Right. So now I should be able to parse, well, yeah, effectively this is the parser. I should be able to parse that. I won't get that parsing error anymore, but now I'm going to get, needs ref.null. Yeah, okay, I already knew that. Okay, so these lists have become a little bit smaller, but now we're blocked on other things. So we've added BR, labels, return, BRF, and call, which is not nothing. That's really good, actually. To get 5 of those test files passing in a single session that's probably the best single serving progress I've ever made on this list, because all of the other things in here are extremely hard won and have taken me, like these float ones didn't come easy. So that's all right. Let's just, before I stop, I just want to have one last look through here and see whether anything falls out that I think, it's like there's block. What happens when I try to run block.wast? Oh, that's just going to be params again, isn't it? I didn't think of that. So what else have I got here? Still stuck on the BR table. Call indirect. I must have done const, surely. Why have I not... Why is... Oh, it is in there. It's just wrapped. Okay, phew. Conversions. Probably not ready for that. What does endianness do? Oh, yeah, okay. So this is relying on stuff I haven't implemented yet. Floats. I remember you well, my friends, but you are now dead. Func. I haven't got global.wast in my list, but I think I should. If only to stop me rediscovering the same problem every single time. If I have to discover that problem one more time, I'm gonna lose my mind. Okay, labels, linking, no. We've got all the locals, get, set, and t. In fact, we've got local set and get, but we haven't got local t. Is that merely an oversight? Yes. In fact, it's such an oversight that I'm just going to put it here, because I'm sure that would have been passing. Does t go with set? It does, doesn't it? Oh, damn. Let's do them in the order that I actually did them. Support table names. Oh, what? Oh, dear. Okay, fine. So this is add local t.wast to parsing tests. I'm pretty sure this is an oversight and it should have been added at the same time as local set.wast, since both instructions share an implementation. Okay, so that's, there was one that I'd missed. Loop and memory we know are not good. Memory init. No, again, that is depending on stuff I haven't implemented yet. Memory size. No, that's depending on growing, which I haven't implemented yet. What's names? This is just checking that I'm using Unicode. That goes a pretty long way, but names.wast needs import spec test, whatever that is. I've seen that before, but I don't know what it is. Have I already got NOP? The answer to that question is NOP. Oh. Nop.wast needs memory.grow. Okay. Return, select, we've already looked at. What does stack do? Oh, interesting. Interesting. This does look like stuff that ideally would pass. I'm sure it won't because I will have messed this up somehow, but this looks like these are all instructions that I've implemented, so this should be on my to-do list. In interpret script, one funcref equals 1 does not return true. So that's a problem with parsing. Funcref. Table 1 funcref. What the heck? How can that possibly work? So it looks like this is just trying to check syntax. Like, this just needs to parse successfully. So I don't really understand what this is supposed to mean. I guess it's saying that you can specify the index of the table. That's weird. Okay, well, that's not easy. It's not completely straightforward. I mean, okay, I can just bodge this so that that parses successfully. Like, it doesn't have to have elements. And this doesn't have to be. You know, if apparently this can also be an integer. Yeah, I mean, I really want the AST parser for that regular expression, don't I? It's this one. Like, I'll call it name for now, but that's probably not right. Oh, what have I done? Oh, I've just not balanced my brackets correctly. Oh, yes, okay. So this is actually a single element of the array. And then at this point, rest has to be empty. Oh, wow. Okay. Boom. One final allow table name to be a number. Let's say allow more flexible table syntax. In stack.wast, there's a table with no elements. Is that the right word? Yeah, no elements and a numeric name, which I expect is its index. But for now, we only need to be able to successfully parse this, not make sense of it. Okay, and then that means that I can add. Wow, so that's amazing. All of this stuff. I mean, is this even being invoked? There are some assertions in here, right? Yeah. So this looks like a real stress test of the stack handling. And it appears to all be passing, so that's great news. I'm very happy about that. What a treat to end on. Add stack.wast to parsing tests. Let me just deal with the spam in the live chat. There we go. Amazingly, this appears to be passing now that I've dealt with the table parsing, now that I've made the table parsing slightly more flexible. Fantastic. Oh, what? What? Why is local T not passing? Oh no. I've broken something. I mean, it looks like this is to do with parsing the... It looks like I've broken something here. Damn. I was so ready to wrap it up and be done, but I don't want to leave it broken. Damn. I don't know what else to say. Oh, actually, look. I was wrong about this. Because it uses tables and call indirect. So it wasn't an oversight. I just hadn't documented the fact that it depends on all this kind of stuff. So this says table funcref lmf. So obviously this was working fine before. So how have I messed this up? So previously it has to match funcref. And then this is the rest of the element, the rest of the command. Oh, that's so... I'm such a... I don't need this. Well, maybe I do. But then this needs to be... That needs to reassign rest, obviously. Okay. Wow. That was frightening. And then actually... interactive would be slightly more helpful. So I snuck it right in there, but I think it should go after call, actually. Unlike local set.wast, this test contains... Oh, depends upon call indirect, which we've only recently implemented. Okay. And then, yeah, there's going to be a merge conflict here because this is about adding stack to the end. Yeah, let's just check. Add stack. Add stack. All right, one final test run for the road. And then I'll push it up. So, I mean, like I said, we've added branch, labels, return, conditional branch, call, local T, and stack. That's 7. All passing. Very nice. What did I say? What was my plan, which I've completely ignored? I mean, recursion does seem to be working, doesn't it? So, whatever. Haven't done that yet. I have done that. It hasn't unblocked loads more tests, but I've got the ones that it did unblock, I've got them passing. I haven't hit my stretch goals, but let me push this up. I have done the majority of that, and I've got 7 new tests passing, which I'm very happy about. So let's just see this pass on CI, and then we'll be done. Come on. These tests are getting slower and slower. Go green. Maybe I need to do this. I need to do this before the end, so that there's, you know, a few minutes for this to run without me just sitting here staring at it, because this feels like an anticlimactic way to end the session. But there we go. Maybe it's not anticlimactic. Maybe that's the best climax imaginable. Okay, well, I guess that's it then, isn't it? I'm now very sleepy, and I've made a series of silly mistakes because I'm getting sleepier and sleepier, so I'm going to call it a night. But like I always say, I'm super grateful that you're giving this your attention. If any human being ever hears me saying these words, then I'm extremely grateful to you for paying attention to this never-ending project. I hope you're getting something out of it. I'm still enjoying this. It's obviously laborious, but, you know, it's a labor that I find satisfying. And I've now generated more stuff that I need to clean up, and so I think the next session is going to be some cleanup. But I'm looking forward to that. It's nice having something to tinker with. So I will say bye for now. Yeah, thanks again for watching it. I'll see you for the next one. Bye-bye.